In this course video, I will take you step by step through the complete structural design and detailing of this three-story residential building sitting on a weak soil using a beam raft foundation. We began with the structural framing, where I explained the governing rules and engineering principles behind beam, columns, and slab placement. We then move to modeling in ProtaStructure, where you will learn how to apply loads correctly and even introduce hinges to release moment and save cost. From there, we go into analysis and design, where we carefully analyze the forces acting on every structural members, that is columns, beams, and slab, and then provide reinforcement to counter those forces, which is design. Then next, we move into modeling and design of this beam raft foundation, where I explain everything you need to know, the reason why we chose this beam raft foundation, which is as a result of the weak soil, knowing fully well that path-based footing will not be able to spread the load coming from this structure to the soil. I will show you how to perfectly design a beam raft foundation and governing principles behind that. Then after the design, we entered detailing, because knowing fully well that a good design will fail without accurate detailing. We detailed the raft slab, showing why the moment acts at the top and not in the bottom. We then moved to beam, where we explained the importance of web bar, and finally we went into columns, beam, and slab detailing of the superstructure. Every principle is explained, every detail explained. By the time you finish this course video, you won't just understand how to design and detail a building like this. You will be on your way to becoming a confident and competent structural engineer. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering, and in this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This is the floor plan of the three-story residential building. We will be carrying out each structural framing. And once I zoom out, you see this is the 3D view of the three-story residential building, and this is also the 3D view. So this is the roof plan, and this is the front elevation, while this is the back elevation, and these are my side elevation, and this is my sectioning. So but in this video, we will be carrying out the structural framing of this three-story residential building. So first, once you get your architectural plan from your architect, the first thing to do, the number one thing to do, is to first of all copy it out. Yes, the first thing to do is to copy out this architectural plan. Reason is because you know that we'll be placing our columns, we'll be placing our beams, even our slabs, and doing this column placement and everything, we'll be deleting some certain features in this building. For example, we'll be deleting the dimension, the furnitures, and everything. So we'll do copy this architectural plan out in case whenever we need to reference it at any point, we'll just easily access it. Yes, so the first thing I'll do is that I'll come and copy out this architectural plan. So once I've highlighted this, I'll do CO, enter. CO stands for copy. Then I'll copy this and I'll like to place it at this point. So this is where I'm placing it. So if you see I've copied it out, I'll click on escape. Then next thing after copying out your architectural plan is to study it. Yes, make sure you study architectural plan. Reason why we do study our architectural plan is to know what the building is used for and to know the features of the building. For example, is it a residential building or is it a commercial building? You know that a commercial building and residential building, they will not have the same loading when you are doing your design and analysis. Yes, so you know, is it a residential building or is it a commercial building? Even if it's a residential building, yes, you also check the residential building. Are we having any gym area? Because you know that if we have any gym area, the loading on that slab will be different, in the sense that gym equipments, they have high load, like they are heavy, they are all heavy equipment, and two, they will be contributing higher load on the slab. So the slab, those slab, the gym slab will not have the same loading with other slab. These are the things you study in your architectural plan, and also study whether your architectural plan has a basement, because if it has a basement, if we are carrying out our structural framing must be done on the ground floor plan, not on the basement plan. And if it has a basement, you should know that you'll be having concrete walls to retain the soil. So, and also you check whether there is an offset or any cantilever. Yeah, on any cantilever. But if you check here, we are not seeing, there's no cantilever in this building. Yes, so that means this floor plan is typical from the ground floor to the roof level. So that's what is meaning. Even if you check here, because this is the ground floor and this is the first floor to the third floor, so the floor plan is typical. These are part of the reason why we will study our architectural plan.
Do you want to master structural design in just 10 days? I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube. And think about it, if my free lessons are already this good, just imagine my paid courses where I poured out all my knowledge and real-life experiences. This 10-day structural design masterclass is all you need to become a confident and competent structural engineer. And the best part is, it is affordable because I consider that most of you are still students. So click the first link in this video description and access the course.
And also, in the case of studying this architectural plan, you will see that here that this place is the same with this. Yeah, they are typical, they are exactly the same thing. So after studying your architectural plan, next thing to do is to delete the things that are not necessary to us as a structural engineer. Yes, not everything found on this drawing is necessary to us as a structural engineer. That's why we made a copy, so that we will delete things that are not necessary to us in this architectural plan, while the original plan will still have it. So coming over to this point, some architectural plan will be having all these furnitures, chair furnitures, kitchen furnitures. Those things are not necessary to us as a structural engineer. We won't be needing it. Even the grid line, the dimensioning, and all these things, they are not also necessary to us as a structural engineer. If we want to dimension anything, we will dimension it by ourselves. So right now, what I will do is that I will be highlighting everything that is not necessary to me as a structural engineer. For example, the grid line. For example, the dimensioning and others. So what I'll do is that I'll come over and I will highlight them, and also come and highlight this. Then I click on select similar. So once I click on select similar, I see everything has been selected. Even this, we have something selected here. So I'll come and deselect everything that I'm having here. So what I'll do is that to deselect it, I'll hold my shift key, then highlight it. So once I hold my shift key and highlight it, if you see everything here has been deselected. So what I'll do now is that I'll come over to this point. Remember, I want to erase everything here. I want to erase everything that is not necessary to me as a structural engineer here. So I'll type E, enter. So this is what I'm having now. So if you can see, I'm not having a very clean drawing. Yes, I'm having a very clean drawing that I can easily work on. So after deleting everything that is not necessary to us as a structural engineer, next thing to do is to create two layers. Yes, create two layers. One is the column layer and the other one is the grid line layer. The reason why we are creating this layer is because we'll be importing these layers in AutoCAD and ProtaStructure. Yes, if you do not create them, you'll not be able to import it in ProtaStructure, and to your work will not be easier in ProtaStructure. So for that reason, I will be creating grid line layer and I will be creating column layer. And once I go to AutoCAD, once I get to ProtaStructure, I will import those grid line and column layers and then easily model it in ProtaStructure. So I'll type layer. Yes, I'll type layer. Click on. I made a mistake. So I'll type layer. Click on enter. So once I click on enter, this dialog box will appear. So I'll come over. Look at this point. It's called new layer. So I'll click on it. Once I click on it, I'll now type column. Yes, I'll type column, but I want to use column Y. Column Y. Y stands for YouTube because this is a YouTube video. So I'll do column Y and I'll click on enter. Once I click on enter, I'll write the color to be, I like to have, I want to use this color and I'll click on OK, and I'll like my line width to be 0.5 because this is column. So this is column. I would like it to be visible. So I'll like my line width to be 0.5 and then I'll click on OK. So at this point, I'll create another layer. Remember, I'll say we'll be creating column layer and grid line layer. So I'll click on this new layer again and then I'll create grid layer. So I'll type grid, but I want to use grid Y. Y stands for YouTube, and then I'll also click on enter. I'll leave it. I want to choose this color. I'll click on OK. Then I'll leave this, the line width should be this 0.00. Yeah, for grid line. Your line width should be the least line width. Yes, I'll click on OK. Then after creating these two layers, I'll come over to this point and then click on exit. So the first thing I want to do now is to create my axis. which is my grid line. So I'll come over to this point and locate the layer that I just created now for axis for grid line, which is grid Y. I'll come and check for grid Y. So where is my grid Y? This is it. So I'll come and select it. Once I select it, remember we want to create our grid line here. So we want to create our grid line. So I'll type L, enter. Once I type L, enter, I'll say from here to, okay, I'll turn on my auto key by clicking on Ctrl F8. My auto key will be turned on. So if you see now, it's already on. So I want to create a line from here to here, and also I will escape, L, enter. I also will have a line from here to here. Reason for this line is so that we'll be able to locate the center of this block wall. Yes, if you do not create this line, you'll not be able to locate the center of this block wall, because our grid line should run across the center of this block wall. So after creating this line, I'll now do SL. I'll do SL. SL stands for construction line. Enter. So once I do SK, enter, I'll do V. V stands for vertical. Enter. Then I'll come over to this point. If you see, this is the center of this line. I'll press this thing here. I'll escape. I'll do SL again. Enter. And then do H. H stands for horizontal. Enter. Then I'll come over to this point and press it here. After doing this line and this line, they are no longer necessary to me. So I'll click E, enter, and then delete it. So this is what I'm having now. Look at this, is a construction line, so it's running throughout this whole AutoCAD interface. But after, I will show you how to trim it off. So right now, the next thing we will be doing is that we will place this grid line in anywhere we are having block wall. Yes, we will place it in all our block wall. This architectural plan, we will place this grid line along inside all our block wall. So what I will do now is that I'll come over to this, click on it, then do CO. CO stands for copy. Enter. Then I'll copy it from this point. Then anywhere I'm having block wall, I'll place it there. So I'll place it here. This is a vertical wall. This is a vertical wall. I'll also place it here. Anywhere that I'm having block wall, I'll place this grid line there. So I'll place it here. Let me check. Am I through? I will not really place it here because this is 6 inches block wall. That is 150 millimeter block wall, but this is 250 millimeter. This is 225 millimeter block wall. So I'm not really place grid line here. So I will leave it. But after, don't worry, we'll see how we'll go about it. I'll place a grid line here. I'll also, I think we are through for here. Then at this point, I'll place a grid line at this point, and then at this point, I'll place a grid line. I'll place a grid line at this point, and I'll also place a grid line. Just place grid line in all your walls. Yes, you must place it in all your walls. Then after, anyone that you don't need, you can delete it. Yeah, after anyone that you don't need, you can delete it, but at first place it in all your walls. So I'll not place it here because this is a dot, and also this is 6 inches block wall, that is 150 millimeter block wall. So right now I think I have placed grid line in all my walls. So I'll escape. Then I'll come and copy this horizontal grid line, do CO, enter, and still repeat the same process. So I'll copy it from this point, and I will place my grid line at this point. I'll place another grid line at this point. I'll place another grid line at this point, and I'll also place another grid line at this point, and I'll also place another grid line at this point, and then finally I will also place at this point and also at this point. So let's check, have we placed grid line in all our horizontal walls? Yeah, I'll also place here. Then have we placed grid line in all our horizontal walls? Place it in all your walls. Then after, anyone that you don't need, you can delete it. So I think that we have done justice to that. Okay, look at this. We have not placed here. Yeah, so right now I think we have done justice to that by placing grid line in all our walls. So I'll click on escape. Then I'll come over. This is like I said before, this is a construction line. So I'll click on left angle. You can just type REC. That's REC. Like, enter. Then I'll now do a rectangle around this my architectural plan. So I like to have a rectangle right this. Once I have this, then what I'll do is I'll highlight this rectangle. Make sure you highlight the rectangle, because if you don't highlight the rectangle, maybe you delete from here to here, why you still be having this line continue from this side. Yeah, so make sure you highlight the rectangle, then type TR. TR stands for trim. I'll click on enter. So I'll come trim of this, I'll come trim of this, trim of this, and trim of this. So if you zoom out, you see those construction line is nowhere to be found again. I'll escape. Then I'll now highlight this, click on E, enter. So this is what I am having now. If you can see, I've successfully placed my grid line. So next thing that I'll be doing now is my column placement. For me to start placing my column, I'll also come over to this my layer and select my column layer, which is column Y. So I'll just come over here and locate C. So locate C to select my column layer, which is column Y. This is it. So I'll come and select it. So once I've selected my column layer, then I'll come over. Remember, I would like to be using the column size of 225 by 225 because the block wall they are using here is 225 by 225. Let's click on this. We are having from this point to this point. Look at this, it's 225 by 225. And I also right click again. We're having from this point to this point. So if you see, our block wall is 225 by 225. So in this case, I will be using the column size of 225 by 225. In which 225 by 225 is the minimum column size that you'll be using. Yes, but you know, this is a 3-story residential building. So there's a possibility that 225 by 225 block wall will fail. But if it fails, then we will not increase the size of that section that failed. But that will be in ProtaStructure. So that is why you need to follow this video till the end. So you get to learn everything concerning residential building design.
Do you want to master structural design and detailing in just 10 days? I created a course where I carried out the full structural design of this residential building from start to finish. In this 10-day structural design masterclass of this residential building, we carried out the structural framing, modeling, analysis, and design every structural members. We analyze the forces acting on them and design reinforcement to counter those forces. From there, we move into foundation detailing, part-based detailing, column detailing, slab detailing, even staircase detailing. We also sectioned and detailed our staircase and slab. And finally, I showed how to print and present your drawing professionally. This course is highly in-depth because I poured out my knowledge about structural design into it. Honestly, it's more in-depth than all the free structural design videos on YouTube. And think about it, if my free lessons here on YouTube are already this good, just imagine my paid courses. This is all you need to become a confident, competent structural engineer. It is an investment you will never regret in this life because remember, the greatest investment with the highest return is the one you make on yourself. And the good thing is this course is highly affordable because I consider the fact that most of you are still students. The link to this course is in this video description. It is the first link you will see. Go and enjoy every bit of the lesson. Do you want to master structural design in 10 days? This course will get you there.
So I'll come over to this point and then type on rectangle, leg, enter. Make sure that you use rectangle because if you use normal line, ProtaStructure will not recognize normal line as your column member. So you either use rectangle or you use polyline. Yes, because these are the two lines that ProtaStructure will recognize. But for normal line, ProtaStructure will never recognize it as your column. So make sure you use rectangle or polyline. So I'll first of all click here. Then I'm using column size of 225 by 225. So first of all, you type at. You must put at 225, comma, then 225. Then you now click on enter. So this is my column. Yeah. So since I've gotten this, let me also say something. Column placement is solely dependent on the engineer. Yes, my column placement can differ from your column placement. Yes, but the thing is that the engineer needs to follow the governing principles in column placement in order to place his column well. Because once it comes to structural design, two things are of necessity to us. First, safety. Second, economy. If your building is safe but it is not economical, you are not a good structural engineer. But safety is our priority. One thing with all these builders and masons that we are seeing out there is that let's say that they prioritize safety, but they don't have any idea of economy. That's why if you come to their building, you'll be seeing column all around. They'll scatter column around this whole building, and which will not make the cost of the building to be high. That means they are not economical in their design. That is why we are better than them because we are engineers. We have been educated that economy is also part of the things we need to consider once it comes to structural design. So I'll copy this thing and see, enter. If you are placing your column, make sure you place them at anywhere you're having wall intersection, or make sure you place them at any point you're having wall intersection, and to make sure that your column is inside your block wall. For example, don't place column in any of your window. Yes, I forgot to mention something. If you are deleting the things that are not necessary to us as a structural engineer, please don't delete your windows and your doors. Yes, because if you delete your windows and your doors, you might mistakenly come to this point and place a column, not knowing that this is a window position. So once you are deleting things that are not necessary to you as a structural engineer, please don't delete your windows and also don't delete your doors, because you might, for example, there are some buildings that have done their design at the edge here. Yeah, at the edge here, they will be having windows at the edge here. Yeah, this is the architect might decide to put a window here. But if you delete your windows and your doors at first, that means you might mistakenly come and place a column here, so which is not proper. So first, don't delete your column. So I'll be placing my column members. But and also another governing principle in column placement is that your column spacing should not be more than 6 meters. Yes, it should not be more than 6 meters. For example, from here to here should not be more than 6 meters. Reason is because you know that from here to here it is a, let me escape. Reason, from this point to this point it is a beam that is connecting these two things. Yes, it is a beam, and if your column spacing is more than 6 meters, that means the load coming to that beam will be high. Remember, the formula for simply supported beam in a the formula for maximum moment in a simply supported beam is WL square over 8. Yes, if you can see, we're having WL square. You see, L is squared, that is the length is squared. That means the more the length, the more the moment, and the more the moment, the more the reinforcement that you are going to provide to counter that moment, or the more the bars you are going to provide to counter that moment. And the more you are providing these bars and or increasing the beam depth, you are no longer being economical in your design again. So make sure that, but this is only applicable to solid slab. You know, we have different type of slab. We have solid slab, we have waffle slab, we even have flat slab, and many even hollow coil slab. Yes, but this is only applicable to solid slab. Yes, it is not applicable to flat slab, and it's also applicable to waffle or lip slab. So make sure you limit them to 6 meters to avoid high moment on your beam. But don't worry, we'll still explain this thing more during our structural framing during this video, during the course of this video. So I'll place here. After, I will now start checking whether it is less than 6 meters or is it more than 6 meters. So, but let me just place column at the points I believe that I should have column. But I will not place any column here for now. If you see, this side is setting as this. So after placing column here, I will now mirror it to this side. Yes, after placing at this point, I will now mirror it to this point because they are typical. Then I will also like to place a column here. Don't worry. Hey, we will not place a grid line here. We will not place a grid line here. So let me, I will just escape. We not, oh, okay, sorry, you place, look at, I'll place a column here instead of placing here. I'll now place a column here. So let me go and copy my column again. I'll click on C, O, enter. Don't forget, please, if you can get the CAD file of this architectural plan and practice on your own. Yes, it is very important. It is very important. You can get the CAD file. The CAD file comes with the structural detailing. Yeah, look at it. The structural detailing has already been done. For example, look at these are column detail. These are first floor beam and column layout. These are foundation detail. So the detailing has already been done. So if you get the CAD file comes with the architectural plan and also comes with the structural detailing. Yeah, in case after your modeling, analysis, and design, and you enter the detailing, in case you need to reference anything, in case, for example, you don't know how to section your slab, look at it, it's already here. You can easily reference it and section your slab. But don't worry, we'll also be doing the structural detailing of this 3-story residential building during the course of this video, so you don't need to worry about, but just get the architectural plan at least to support the channel and also to practice and develop yourself, because practice makes perfect. Yes, the more you practice, the more you get to learn it, and the more it gets to become part of you. So you can get the CAD file, and to don't also forget, you can also share this video in your class group or anywhere, so that more people will get to learn, not just only you. So I'll place a column here. Then after, I'll now start checking, is it more than 6 meters or is it not more than 6 meters? So I also like to have a column placed at this point and a column placed at this point here, at this point and at this point. So coming over to this point, I would like a column placed at this point. Yes, and I will also like a column placed, right? Is that I place a column here or I place a column here? But don't worry, after I'll come and explain something around this area. Yeah, then I also like to have a column placed. I would like to have a column placed here. Yes, don't worry, after we'll still explain more on this. I like to have a column placed at this point, and I also like to have a column placed at this point and also at this point. I'll come now and come and start checking my column placement to know whether it is less than 6 meters. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group, so that more people will get to see this and they will also learn alongside you. So in checking whether your beam placement is less than 6 meters, I'll come and click on my dimension. So I'll check what is distance from here to here. I'm having it to be 3.225. I'll also click here, check what is distance from this point to this point. Yes, I'm having it to be 2.025. So if you can see, this is less than 6 meters and also this is less than 6 meters. That means it's okay. But I'll come and still check on one thing. What is distance from this point to this point? So look at it. I'm having 5.25. Yes, 5.25 meters. Remember what I said? Once it's less than 6 meters, yes, a beam can run once it's less than 6 meters. Because of one, our priority is safety. Then after safety, you see economy. So having a column here, a column here, a column here, yes, the structure will be stable. Safety is in view. But also having a column here, here, and here, economy is no longer in view, but safety is in view. But our aim is to make sure that economy is in view and safety is in view. So for that reason, I'll be removing this column. Also, another reason why I'll remove this column is because we are having slab here, yes, so there will be load coming from this slab to this beam. This slab will transfer its load to this beam, so, and there is no slab here. So if you can see, this beam now will carry only load coming from this slab. So that means there is no much load coming to this beam. So these two reasons, there is no need why I will have this thing here, because of safety, because of economy. So, but you should know that after design, there is probability that we might be having here to be 3y16. That's the bottom bar, 3y16, or maybe let me say at the end, maybe at the center. Don't worry, I will see explain later. But let me just explain what I want to explain now. Maybe after now, we'll be having here to be 3y16. That's after we have removed this. Yes, we'll be having to be 3y16 maybe. So most of the clients, they don't really like when they are seeing 3y16 in their work. They will tell you that I did this project here, they use 2y16 or throughout. Why is it that your own I'm seeing 3y16? Are you sure you know what you are doing? You have to explain to them. Maybe the person that did the work is all these artisans on site. Once, if he's an amateur engineer, he will place column at all round. He will place column here, he will place column here, and he will place column here. And if you place column here, let me tell you, if you place a column here, that means this beam must surely be under 2y16, is a must. But the thing that it will be under 2y16, but economy is no longer in view, because if I remove this column and have 3y16, I'm still making profit. Like I'm still having economy in view, because I will just, because this column now consists of 4y16 and your concrete. Yeah, but if I'm able to remove this and just have only 3y16, that means I did a good job. So these are the things you have to explain to the client, so he will not take you as I say casual, or just somebody that doesn't know what he or she is doing, because you know that they lack knowledge. Yeah, so you have to give them the proper information that they need to work with. So if you just explain this, like if you finish explaining this now to them, you see that next time they will call you, because they have seen that you know what you are doing. It's not that that you are doing guesswork, but you know what you are doing actually. So I'll just click on enter to delete this, because this is still less than 6 meters and it's carrying the load coming from this rack alone. So I'll also come and shake for this side. I'll click on my dimension. I'll check distance from this point to this point. So I'm having it to be 3.45. So it's okay for me. Then I'll also right click again. I'll check what is distance from this point to, okay, let me check this point to this point. Then I'm having 1.4 is okay. It's less than 6 meters. Then from here to here, I'm having 2.4. So that means the total, let me check the total. Let me check the total. The total from this point to this point, I'm having it to be 3.825. So if you see, this is less than 6 meters. But for me here, I will leave this column here. Yes, I'll leave this column. I'll tell the reason why I chose to leave this column. But I say structural framing is totally dependent on the engineer. Another engineer might decide to remove this column. But for me, I want to leave this column. Reason is because this now is a joint. Yeah, this is a joint. Look at this, is an intersection between this wall and this wall. And if you see, this is a very long wall. Yes, this is a very long wall. This is not a short wall. If you see, it's 3.45. So if this wall come and intersect with this, if I leave it like this, maybe in future or thereabout, there might be crack. I don't say there will be crack. I say there might be crack. So for that reason, I would like to have this column here. And also, this is an outer joint, in the sense that this is our surrounding and this is our this is the outside. That's the surrounding, the environment. Why this is the bedroom, yeah, inside the building. So for that reason, I would like to leave this column here. But another engineer can decide to remove it. It will still work. Also, another reason why I would like to leave this column here is because this beam now, this beam will share its load between this column, and will share its column between this column or this beam and this column. You understand? That's this beam now. It will share the load I is getting from this slab between this column and this column. That means if I leave this in here, there will be a point load here, but that's not a very strong reason. But I just want to leave this in here because of this is an intersection and is also an outer intersection, because this is the surrounding and this is the inside. So I'll leave this column here. Then I'll right click again, click on my linear. I'll shake from this point to this point. Sorry, I made a mistake. I'll right click on my linear. I'll shake from this point to this point. I'm having 3.8. I'll also click on my linear again, shake from here to here. So if you see, that means a beam should be able to run through. Yes, I'm having 5.4. So for me, I'll remove this column. Yes, I'll remove this column based on the things I explained here. But let me explain it one more time so you understand. First reason is that this column now is carrying just the load coming from this slab. There's no slab here, so it is not carrying any load from this slab. It's carrying only the load from this slab. So for that reason, is not carrying much load is not coming to this beam. Also, another reason why I remove this beam is because this is less than 6 meters. Look at it, it's 5.4. So first, it's carrying a lesser load and it is less than 6 meters. Don't forget what I explained there. Maybe after design now, I'll be having 3Y16 here. If you have 3Y16, it's okay. Yeah, it's still okay. Maybe your client might have done works or projects that all through it is 2y16, 2y16. You should be able to explain as an engineer. Maybe in the one that he carried out, the project that he carried out, he has a column here, here, and also here. Because if you have column, this point, this point, this point, there will be high probability that you'll be having 2y16. Yes, there is high probability that it won't be 3y16. But if I'm having 5.4, there is high probability that I'm be having 3y16 here. So explain to that to that client that you are trying to save cost. That's why you remove this column and then replace it with 3y16 instead of 2y16. If you check the cost, because column consists of 4y16 and concrete. Yes, if you check the cost, you see that he is making profit, but he doesn't know that he's making profit. He thinks that he's making a loss. Yeah, because you know what client, even if you place 40 columns here, they will not ask you any question about it. But once you start having 3y16 in your beam, they'll start thinking, hey, this guy doesn't know what he's doing. But if you have column at every joint, they will not consider it as anything. That's just the thing. So you have to explain to them. So for that reason, I'll remove this. Let me escape. I'll remove this. Enter. I'll delete it. Then I'll be having my beam. I'll be having my beam long like this, and then a beam will also and unless this beam now will run and rest on this beam, because a beam will run from here to here, so this beam will run and rest on it. So that's how it will be. So I'll come over to this point. This one definitely it should be okay. I'll click on my dimension and check what is done from this point to this point. So I'm having 3.97, so it's okay, it's less than 6 meters. So I'll also come and check this top one. I'll right click on linear, I'll check from here to here. So I'm having 3.825. 3.825 is okay. So I'll also check from this point to this point. So if you check now, if you do this plus this, is less than 6 meters. But I'll leave this column here and also leave this column here. Reason is because there is no, here is a void. This is a void. That's the reason why I'm leaving this column here and here. Assuming right now I'm having a beam running through, I will remove this column. You understand? Assuming I'm having a beam running through, I'll remove this column. But since here is a void, look at where our beam is. This is where our beam should be. Yeah, we should place our beam here. Since here is a void, I'll leave this column here. I'll leave this column here because I would like the column to be at this wall intersection and also at this wall intersection. But if assuming I had a beam running through, I'll remove this column to save cost. So I'll leave this column here. So I'll right click again for my linear and check distance from here to, let me just check straight. So I'm having this to be 5.55. I will remove this column because first, it is less than 6 meters. Second, it's carrying the load just from this slab. There's no slab here. There's no slab here. It's carrying only load from this slab. So it is less than 6 meters and it's carrying load from this slab. So for that reason, I will remove this column. Don't forget again, if you remove this column in your design, you might be having 3y16. Leave it, is okay. If the client should complain that he's having 3y16 but other project is 2y16, explain to him. He doesn't know. Most of those projects, maybe they're having column here and having column here and also have column here. If you have column here, here, and here, your work must be 2y16 is a must. But if you remove this, that means the probability of you having 3y16 have increased. Yeah, here might be 3y16, but even though it is 3y16, you are still saving cost. You are still economical in your design because the cost of this column now, this is 4y16 and a concrete. But if you remove it and just replace it to just one bar of y16 of 5.5 meter length, that means you save cost. But the client doesn't know because all the work they have done is that maybe they will have column placed at all, maybe they will have column here, maybe they will have column here, here, and also in this case they'll have column here, and here they'll come and have column here. They'll have column placed all around the building. Then they'll think it's normal, but they don't know. And the more you are placing column, the more you are having 2y16. So that's what they don't know. But you have to educate them so that they will know. So at this point, I'll come and check here now. If you see here should be if you check I should have a column along here. Yes, so I'll copy one of this column. I'll copy this column and do enter. I'll copy it and I'll place my column at this point. Yes, I'll place my column at this point and then I'll come and check my dimension again. I'll check from this point. No, I'll right click. I'll check from this point. From this point to this point, what am I having? Oh, I made a mistake. Okay, yeah, I'm having 5.25. Okay, I'll also check again from this point to this point. Sorry. Let me just escape. Let me right click again. That's to repeat linear. I'll do from this point to this point. So I'm having it to be 4.125. So if you see this beam here, this column here is okay. I don't need another column. But if it's all these artisans on site, they'll place a column here, they'll place a column here, and then here. They'll be having four columns here. But me, I have only three. 1, 2, 3. And since I have placed 3, the probability of me having 3y16 is high. Yes, but if you are placing, assume I remove this column now, assume I removed it, enter, and then copy this one. Let me say sorry. Let me say I went with this. Assume I remove that column, and I'm having something of this nature. I placed a column here and I placed a column here. Yes, that means the probability of me having 2y, that means I'll be having 2y16. Yeah, I'll be having 2y16 here, 2y16 here, and 2y16 here, which is normal. But since I've removed this 2 column and just replace it with only 1 here, that means I might have 3y16. Do you understand? Let me do Control Z, Control Z, and also Control Z, sorry, Control Z, Control Z, Control Z. So I'll have this column here. And also the reason why I left this side is because this is a void, this is a staircase. So that means this is a void. This beam is carrying load from this side alone. And so for that reason, I've done my column placement. I hope you understood the principles I explained and things that I explained. So I will click on this, click on select mirror, and then do E, enter to erase all of them. Then
if you are a structural engineer, this is for you. Most structural engineers are taught plenty of theories in school, but here is the truth. Theory alone don't design a safe structure. You have probably heard, just follow the code and it will work. But get this, even with the code, many engineers still struggle to produce professional structural drawing. That's exactly why I created a 10 days intensive structural design and detailing masterclass to show you step by step how the structural design is done in practice, and this course is designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day 1 of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about part-based footing detailing. Day 6 column detailing. Day 7 beam detailing. Day 8 slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10 you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan, and finally you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally access to our online engineering community, where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
And right now, what I'll be doing is my paneling and beam placement. Paneling and beam placement. Once it comes to paneling, the thing you should know is that your panel should not be more than 30 meters square area. As your slab, panel is slab. It should not be more than 30 meters square area. For example, let's shake. We are shake from this point. We shake what is the from here to here. I'm having it to be 3.825. I'll right click again. I'll do from here to, okay, we see that this, I'm having to be 5.25. So if you see this one, this, if you do 5 times 5, 5 times 5 is 25, but I'm having 3 here. So that means this is not up to 30 meters square area. So that means I'm okay to call here my panel. But if if this panel is more than 30 meters square area, there are two things that you can do. Is either you increase your slab depth, that's you might move from 150 to 175, or you introduce a beam introduce a beam here to demarcate this. So here will be one panel and here will be one panel. So it's either you increase your slab depth or you introduce a beam to cut this slab. Maybe you introduce a beam here and a beam here. So you divide this slab. Here will not be one panel and here will be one panel. But note that this slab area should not be more than 30 meter square area. It's only applicable to solid slab. Yes, it is not applicable to waffle. It is not applicable to flat slab. It's not applicable to rib slab. It's not also applicable to hollow coil slab. It's just only applicable to solid slab. So these are the things you should know. So since I've said that the whole of here should be one panel, I'll delete all these things. Yes, I'll delete all of them. I'll delete all of them because I want to have here as one panel. I'll also delete the whole of this. Yes, I will do okay. I'll also come over here and delete this and then do enter. So this is what I'm having now. Then what I'll do now is I'll come over to this point, click on this ES, enter. ES stands to extend. I will extend this and I'll also extend this. ES is for extend. I will extend this and I'll also extend this. So this is what I'm having. I'll also come over to this point. I'll click everything, do ES, enter. So I'll come and extend this and also extend this. Yes, so I'll delete this. I don't need this. So this is now one panel. Hope you understood. So I'll click on this and I'll check from this point. I want the whole of here, both this bathroom and toilet and bathroom, to be under one panel. So so if you see, as me is all these people that don't know anything about structural design, they will place a column here because they are seeing wall here. They will place a column here and also come and place a column here. And if you are placing a column here, you'll be having 2y16. Yes, but since I've decided to have here as one beam, the whole of this length as one beam, that means it is not. That means you'll not be having that means the probability of you having 3y16 has increased. Yes, but don't forget, it should not be more than 6 meters. So, because once it's more than 6 meters, if the moment is very high, it might require you to increase your beam depth, or you might not enter into y20. Do you understand? So just limit it to 6 meters. Yes, limit to 6 meters. So I will right click again, click on my linear that's dimension, and check what is that from here to here. I'm having 5.4 and 3.6. So as me, I'm 30 is 6 times 6. So this is not up to 6. This is not up to 6. That means it's not up to 30 meters square area. So I'll click the enter and then I'll convert the whole of here to be one panel. So I'll do the whole of here to be I want to have the whole of here. I want to have the whole of this to be one panel. Enter. Then I'll also come over to this point and then click on this and also these two things and then these two. Enter. So I want to have everything as one panel. So I'll come over here and select this. ES, enter. I will extend. I will also extend. I will also extend. Then I will escape. Then I don't really need this. I don't really need all this. Yes, I don't need them. So I'll click on enter. Then I will come and click on this ES. ES stands for extend. I will extend this and I will also extend this. I will then escape. So this is one panel. This is one panel. Then coming over to this point now, I want to make this sitting room one panel, and then this veranda and this toilet and bathroom and this toilet one panel. So I'll come and check what is my dimension to be sure it's no more than 30 meters square area. So I'll come and check from here to here. I'm having 4.23. This thing should be 4 point, maybe 25. I don't click it very well. I don't get the edges very well. Okay, look at it. I don't really get it well. So I'll check from this point to this point. I'm having 3.79. Look at, I don't get it well. That's why it's 3.79. So, but if you check, both of them is not up to 30 meters square area. They are not up to 6. That means they are not up to 30 meters square area. So I'll have the whole of here as one panel. So I'll delete this. I'll also come and delete all this. And I'll also come and delete this. And I'll also come like this. And then delete this. And yes, I've deleted this. I remember I said that here will be one panel. So I also like to delete these ones too. I'll also come and delete this. And I'll come over to this point and then delete this. I will then hold my shift key to deselect this, click on enter. So this is what I'm having now. Then I'll come over and select this, click on enter. I'll extend this line and I'll also extend this line. Then I'll escape. Then I'll come over to this point. Then come over and click this and do enter. I'll extend this and I'll also extend this. Then I'll come and click on this. Yes, I'll come and click on this, do enter. I'll extend this and I'll also extend this. Yes, then I'll come over, and I'll come and extend this one. Yes, then I'll escape and then come click on this, enter. Then I'll extend this and I'll extend this, and also I'll extend this and I'll extend. Okay, this line not extend to this place, so I'll just come and delete all these things here. Yes, and also delete this door and window. sorry, this, because it's not needed, I'll delete it. Enter. Then I will click on this, do ESC, enter, and then extend this line. So this is what I'm having now. So this is one panel and this is one panel. I don't really need this staircase. I don't need it. I'll delete it. So coming over to this point, I'll like to make the whole of here one panel. But let's check the dimension. Let's be sure that it's not more than 30 meters square area. For then from here to here, I'm having 5.5. Then I'll click on linear again. From this point, let's check from this point to this point, I'm having 3.25. So this one, none of them is up to 6 meters. It's not up to 6 meters. It's not up to 6 meters. That means it's not up to 30 meters square area. So I'll click on E, enter, delete it. That means I will have the whole of here to be my slab. I thought we agreed that we should delete this column. Maybe I forgot to delete it. We agreed that we'll delete this column, that this is not up to 6 meters and it's carrying load just from this slab. So we agreed that we'll delete this column. Maybe I made a mistake and not delete it. Yeah, I've deleted it now. So I will also come and click on this and do E, enter. So this is what I'm having. The whole of here will be one panel. So I will right click and do E, enter. So I will now I will come here, I'll highlight this, do ESC, enter. I will extend this and I will also extend this, and I will come and extend this and extend this. Then I'll also come here, I'll come over to this point, delete something, delete this is not needed, and I'll also come and delete this, E, enter. Yes, and I'll highlight on this to extend this line. I'll do ESC, enter. Then this, yes, and then I'll come and extend this and also come and extend this. So this is what I'm having now. So that means here is one panel, here will not be one panel, and here will not be one panel. That means I'll just come and delete this because I don't need this again, and also I don't also need this. Enter. Then I'll do ESC, enter. Then I'll extend this and I'll extend this. So this is what I'm having now. Let me trim off this TR, enter. So I'll do, sorry, TR, enter. So I'll trim off this and I'll also trim off this. So okay, let me leave this trimming because this is not what we are here for. So I'll leave this. So if you can see, I've successfully paneled this. Enter. I've successfully done my paneling, both my column placement, beam placement, and also slab placement. So this is what I'm having right now. So what I'll do now is that since here and this side they are the same thing, I'll mirror this to this side because here and here they are all the same thing. Hey, look at what we're having here. I want to explain something here. So if let me click on my dimension. Let's check the dimension that from this point to this point. We're having it to be 2.025. Then I want to check from this point. Don't worry, I want to explain something so you understand something. I want to check from this point to this point. I'm having it to be 4.125. Yes, I also right click again. I will still explain what I'm doing so you understand. Check distance from here to here. So I'm having it to be 4.35. Okay, yes. So right now I want to move this column from here to this point. I will explain. I want to move this column from this point to this point. Look at the reasons why I want to move this column. You know that this beam now is 4.125. Yes, but this beam now is carrying 2-point load. Two, not just one, it's carrying 2-point load. That's the load from this beam and also the load from this beam. So this beam now is carrying its load. Like the slab load is transferred to this beam. Then this beam will now divide it into two. It transfers some to this column and then transfers some to this beam. So this beam now is a point load to this beam, and also this beam is also carrying a point load from this. But if I should move this column to this point now, even though the adherents have increased to 3.25, it will now be carrying only 1-point load. So me, I'll prefer to move this beam to this point because I believe that if I move this beam to this point, that means the load on this column, like the load will be somehow even. Because if you leave this thing like this, the load coming to this structure now, the load coming to this beam now is too high. It's too much. It's too much. But if I should move it, let me do enter. Let me move it so you understand what I'm saying. And place it at this point. Yes, even though this beam now will not be carrying only 1-point load. Yes, only 1-point load. That's this point load. Even though it's 4.35, it will not be carrying only 1-point load. And also the load. Remember, this slab will share its load between this beam, this beam, this beam, and this beam. And then this one will also share its load between this whole beam, this beam, this beam, and this beam. So after sharing, this one will share its beam. Then this beam, after this slab will share its beam between this and this. So this beam now will not share its load between this and this. That means it's half of the load that is coming to this beam. I don't know they understand it, but here this beam now is too long, so the road coming from this will be more than the road coming from this, even though they are in two directions. But this one is a very long beam, and two, this is a very big slab panel. So I don't know whether you understand what I'm explaining, but I'm just trying to explain about moments, because I know that if I should leave this column here and allow this beam to run like this is a point road, this is a point road, I'll be having high moments on this beam. But if I should bring that column to this point, even though this is a slab, this is a slab, at least the point road have reduced, and also the road coming from this slab now is no longer that much, because this is a beam. So the road is just from this small slab, and also from this portion like this, from this portion like this rectangular, yeah, that will be coming to this. So for me, I just prefer it like this. But I don't really understand. I don't really know whether you understood what I explained, but I believe that you understood. So right now I want to mirror. So for me to mirror, I will delete everything here and then mirror this. So I'll come and delete this. I'll delete everything here. I'll click on E, enter. So after I've deleted everything here, let me also delete this dimension because I don't need them. Let me just click on select similar and then do E, enter. Then I'll now come, okay, before I'll do it, I have to locate my base point, which should be here. I'll click on L, enter. So here, from here to here should be my base point. Remember, look at this whole building. Remember I told you it's symmetrical. So the center of this whole line should be within this staircase. It should be the center of this staircase. So look at it. So this thing I did now, I'll be able to locate the center of this staircase using this line. So I'll just come over to this point and then highlight this, do MI, which stands for mirror, enter. Then I'll specify my base point. So I'll turn on my auto key by clicking on Ctrl F8. I'll turn on my auto key, then I'll press it here and then click on no, that I don't want them to erase the main of the erase the source. So I'm having this now. Then I want to ES, which stands for extend. I'll extend this line and also extend this line. Come over to this point, I'll extend this line and extend this line. So I'm through with my paneling. So this is how my beam will run, and I hope you understood everything I did now. So I'll come and delete this. So the next thing that I will do now is what is called superimposing. So I'll come over to this point and do CO, enter. No, sorry, I'll come and click on this. Click on this, right click on select similar. Superimpose is the process whereby we copy the whole column to this first floor and check whether any of the column is causing obstruction. So I'll come over and do, okay, I've done CO. I want to copy from step. Whenever you are doing superimposing, please, okay, CO, enter. Whenever you are doing superimposing, please copy from the staircase, because the staircase will be the same even at first floor, second floor, and third floor. So copy from the staircase. So I'll come over to this point and I'll paste it here. I'll zoom out. So if you see, okay, yeah, thank God, that means we don't have much work to do since there is no column causing obstruction. As soon as I'm having a column here, and that means that column will be causing obstruction. And to the first design that we did, that's in this YouTube channel, the design we did, a column was here and it was causing obstruction. So if you want to learn how to go about that one, you can go and watch that video. The title is complete ProtaStructure tutorial 101 ultimate beginners guide. So you can go and learn, you can go and watch the video so you see how to go about it and also how to model it in ProtaStructure. So right now I'm not having any column causing obstruction, so this is okay. I'm through with my superimposing. That means I can go with this drawing is okay. I'm through with my general arrangement drawing. So next thing now is to save this as a DSF file, but don't forget you can equally get the CAD file and practice. So if you see, we have done everything. Look at it, this is a 3-story building. Look at it, this is the first floor, second floor, and this is the last floor. Yeah, we have done the structural detailing and of everything. So if you get the CAD file of this architectural plan, you also get this structural detail. So in case once you are doing your design and you encounter any problem or face any challenge doing your detailing, you can always come here and reference it to understand whatever you are doing. So we have done it here. So to make it easy for you. So right now, what I'll do now, and also don't forget, if you are finding this video helpful, please, it won't take you anything to just click on the like button. Just click on the right button. It won't even take you 10 seconds. And also share this video. Yes, share this video. Sharing this video now will not really take you up to 10 seconds. Just go to the share link and share it maybe in your class group or in your work group, any of them. So right now, to save this, I'll save it at the origin, because ProtaStructure recognize file saved at origin. Like you easily trace your file or your drawing once you save it at origin in ProtaStructure. So for that reason, I'll save this in my origin. And also, not just that I'll save this in my origin, I'll save it in DSF file. So okay, so to save it, before I'll save it in my origin, I'll come and check which of this grid line are we not making use of. So if you check this grid line, I'm not making use of this grid line. Yeah, I'm not also making use of this grid line. So at this point, you delete the grid line you are not making use of. So this is just the grid I'm not making use of. I'll just type E, enter. Then to locate my origin, I'll type L, enter, 0, 0. So this is, I'll click on enter. So if you zoom out, wait. So this is, I have seen my origin. So look at my origin here. This is my origin. So I'll come over to this point and then do CO, enter. So I'll copy this drawing from this point and come remove my auto key by clicking on Control F8 and locate my origin. So this is my origin. So at this point I will do E, enter, delete design. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside this one. So this drawing now is now in my origin. Then to save it, you highlight it. Once you highlight it, you type W. W stands for web block. W enter, which is web block. Then I'll come over to this point, change this insert unit to millimeter. Yeah, make it to be millimeter. Then I'll come and click on this three dot. I'll click on it. Once I click on it, I would like to save it on my desktop. So I would like to save it on my desktop, and you make sure that this is DSF file because ProtaStructure only recognize DSF file. So I'll click on it. Then I'll now change the name. I would like to use the name 3-story YouTube. Yeah, because this is a YouTube video and this is a 3-story essential building. So I like to use 3-story YouTube. So this is a 3-story YouTube. Then after everything, I'll then come and click on what? Save. And then come and click on what? Click on OK. Then at this point, if I want to see my file, I will just minimize. So look at it here, 3-story YouTube. So I will just double click on this. I'll double click on it. I'll double click on this. So look at it here. Hope you are seeing it. But if you see it like this, don't panic. You just type to bring out the line width. You just type line width. Just type line width. Yeah, this is line width. You now come to this point and click on display line width. Once you click on it, then click on OK. Yeah, you start seeing your line width. So this is it. So now we have saved it in a DSF file, and this is what we'll be exporting to ProtaStructure. So right now we have come to the end of this video. Don't forget, you can get the CAD file and practice on your own. Practice makes what? Perfect. Practice makes perfect. Get the CAD file and practice on your own, because the more you practice, the more you learn. If you watch 100 videos without even practicing anything, and someone else watches only 10 videos and just practice that 10, that person will be far better than you once it comes to structural design, because it's not all about watching. You need to take action and practice, so it will become part of you. So get the CAD file. The link is in the description below, and practice on your own.
Are you a civil engineer, an engineering student, or a builder, and you want to revamp your structural analysis skill? Just hold a minute. This course I'm introducing here is for you. This is a 10 days intensive structural design and detailing masterclass designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day 1 of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about part-based footing detailing. Day 6 column detailing. Day 7 beam detailing. Day 8 slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10, you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan, and finally you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally access to our online engineering community, where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course
Subscribe.
now.
Once you open the ProtaStructure, this is the interface it will take you to. So once you come to this place, you just click on new project. So once you click on new project, I'll write you first of all save it, your project name. I like to save this project with, we are designing a 3-story residential building. I like to save it with the name 3-story YouTube. No, I'll just save it 3 story, then 3-story YouTube. So I like to save it with 3-story YouTube. Then you now come and pick your code, which code you want to design with. So if it depends on your country, any country, and you choose the code. But in this project, I'll be using Euro code. Yes, United Kingdom Euro code. This is the code I'll be using. Then once you have taken your code, this is the template. I'll then click on OK. So once you click on OK, you allow it to load. Yeah, if you see it now, it will be loading. So as you will be waiting for it to load, remember we have done the structural framing of this 3-story residential building. So and the link to that video is in this video description, and there we are able to explain everything you need to know about general arrangement drawing, that's positioning of column, beam and slab, both the governing principles. We are able to explain all of them. So it has opened now. So at this point, what you do now, you come and import that your drawing that you saved in AutoCAD. To import it, you come to building setout, then now come to this external reference drawing. Once you click on it, a dialog box will appear. So you now come to this place that says add DSF. I'll click on this add DSF, then I'll now locate down my drawing. So I saved it on my desktop. Look at it. So look at it. That's why we say that it must be a DSF file. So if you can see, what you're seeing here is just only DSF file. So if it's not DSF file, you will not see it here. So look at it, 3-story YouTube. So I'll click on it and then click on open. So let me arise. So look at it. But if you let's go up. If you see you're not seeing anything here, so I'll just check this. So look at it, it's not appearing. Then you can decrease the color intensity or increase it by using here. Okay, first click on choose color. Then you can increase or decrease the color intensity by moving this. So at this point, I've imported this. Then the next thing to do now is to import my axis, that's my grid line and my column. Then I'll come to this place named import. I'll click on it. So at this point, my column, my grid line, I used it as I set it with grid line. Why? This is why I say that I should create a grid line layer in AutoCAD. So my column, I set it as grid line, so as column Y. So I'll come and click on this. I'll check for column Y. This is it. I'll click on it. Then I'll check it. Make sure that none other is being checked. I'll click on OK. So look at it, I'm having as column Y. Then I'll now come over to this point and then click on import. It will not import. Remember, we have the architectural CAD file of this 3-story residential building in our seller store, so you can go there and purchase it. So you practice on your own. Practice makes perfect, and the more you practice, the more you get to learn. So click on close. Then I'll also come here and then click on OK. So if you see, you have everything has been imported. These are column, and these are axis, the axis I'll use. But once you look, this axis is not being numbered well. Look at it, A9, A8, A9, A10. It's not being numbered well. So I will rename this axis. You can only do this if you are using ProtaStructure 2025 and above. Yes, if not, you do it manually. So I'll just come to this this review. I'll come to review, click on a label member. I'll click on it. Then I'll just click on this my axis. I'll then come over to this point and change it to this, then click on OK. So look at it now, everything 1 2 3 4, yeah, it has been numbered well. So at this point, next thing to do now is to place my beams, because my columns are already been placed. So next thing is to place my beam. So I'll come over to this point, modeling. This is my beam. I'll click on beam. So click on normal beam. A dialog box will appear here. So once this dialog box appear, what is the width, what is the breadth of my beam? I would like to use the breadth of 225. Reason is because my column size is 225 by 225 and my block wall is also 225 by 225. So that's why I'm using 225 column. Yeah, but I don't say it's a must. Once it gets to all this high-rise building, the breadth can change. Yes. Then what is my column depth? The column depth I'll be using in this in this structure is 460. Remember, the minimum column depth that you can use is 300. That's the minimum. Remember, economy, safety and economy is our priority. So I'll first of all go with the minimum because of safety, which is 300. Then if it fails during design, I can now increase it. But if it doesn't fail, that means it's okay. So I'll go with the minimum, which is 300. But don't forget, we have 300 then plus the slab, because this we will place a slab on top of the beam. Yeah, so that's the slab depth is what 150. So it can be 300 plus 150 is what 450. So that's why we are using a column depth of 450. Then if it fails, then we'll not increase the depth. So with this now, what I'll do now is that I'll come over to this point. I'll input my beam. So I'll array it. So look at it. I'll also come to this point and input my beam. Then I'll input my beam here, and I'll also zoom out and come to this point and input my beam. So I'll escape. Then I'll want to input beam from this point to, I'm having it to this point. Then I'll escape. I'll also input beam from this to this, then from this to this, and then from this to this. I would like to explain something. Let me do from this to this. Let me place it here. So if I press it, you are seeing this, this triangular sign. This triangular sign means that this beam is a cantilever. Yes, but this beam is not a cantilever. I'm not designing this beam as a cantilever. So what I'll do is that I'll click on this thing, I'll right click and delete it and delete it. And first of all, I'll double click on this thing again to bring out its property. I'll double click on it to bring out its property. So look at this property. I'll now move this beam from this point to this point. Yes, then I'll now come and do from here to here. Yes, so this is what I'm having. So at this point, this beam now is a primary beam. This one now is a primary beam. Why this is a secondary beam? Because this beam now is being held by two columns. That's this column and this column. So it is a primary beam. And this beam now is a secondary beam because it is resting on this beam. Not just that it is a secondary beam, it's also acting as a point load to this beam, because once the slab transfer its load to it, it will now transfer it to this beam at this point. So it will not be serving as a point root to this beam, not just that it is a primary beam. So I'll still continue to my beam placement. I'll have my beam to run like this, and also have my beam to run like this, and also run like this, and also run like this. Then I'll escape again. I'll have my beam to run from here to this point, then from to this point. Then I'll have it to run from this point. Then I'll also be having this. Yes, I can escape again. I'm having it to move from here to here. Then I'll also escape again, move from here to here, escape again from this point to this point, escape again from here to here. Yeah, we are just following the lines that we did in AutoCAD. Yes, that's why structural framing in AutoCAD is very important, so that once you come to ProtaStructure, you not really waste time. Some people will come and start creating axes in ProtaStructure. Those people, they are just wasting their time, or they are not. I don't know whether they are wasting their time, but for me, I'll advise you do your structural framing in AutoCAD instead of coming here to create your axis. Yes, I will escape and then place this column from this point to this point. I will escape from here to this point. I will also escape then from here to here. I will also escape then from here to here. I will also escape. So I think, have we placed our beam all around? Yeah, so I think we have placed our beams. So I'll come and close this dialog box. So next thing to do now is to input our slabs. Yes, we have to input our slabs. So what I'll do now is that I'll come over to modeling again, to modeling. So this is my slab. I'll click on my slab. Then they are asking me whether that I should define load case. So I'll click on OK. Yeah, that I want to define load case. So I'll come here and click on load generator. So once I click on load generator, everything here, look at it, everything here, this for the vertical load combination. All these things, they are all from the code. They are from Euro code. So you just read them at default. Then I'll come over to this horizontal load. Coming over to this horizontal load, this wind load, I'll check it, because once your breathing is more than 10 meter, the height of your building, once it's more than 10 meter, that means it will be affected by wind. And two, we are designing a 3-story residential building, and two, the height of each floor is 3 meter, 3 meter, 3 meter. So let's go to AutoCAD and check our section, so to know whether what we are having is it more than 3 meter. So okay, look at it. Let's dimension, since they did not give us the dimension. So we're having from this point to this point. So we're having, look at it, 12.736. So if you see the height of this building is more than 10 meters, that means it will be affected by wind. So we will include wind load in our design. So that's why I'll come here and check wind load, because this building will be affected by wind. So as I've done this, then leave everything, then click on OK. Then look at it, they have generated my load combinations for me. So I'll just come to this place and then click on OK. So at this point, this dialog box will appear. So what should I have as the depth of my slab? I would like to go with depth of 150. Yeah, depth of 150. So this depth of 150. Leave it up type 1. Yeah, because this is a solid slab, so leave it at type 1. Then I'll come over to my loading. So this one is the self weight of your slab, so it has been calculated automatically. Self weight is gotten by the unit weight of concrete times the depth of your slab. Now I'll now come over to dead load. What should I have? What is my dead load? Dead load is gotten from two things, which is partition load plus finishes. Yes, partition load plus finishes. So partition load ranges from 0 to 0.5, while finishes ranges from 1 to 1.5. Do you understand? Partition load ranges from 0 to 0.5, while finishes ranges from 1 to 1.5. Finishes is all this tie or in fact your German floor in general. So I would like to be using the finishing load of 1 and a partition load of 0.5. Yeah, so that means 1 plus 0.5 will give me 1.5. So my dead load will be 1.5. Then I'll now have my imposed load. I'll just right click. This is a residential domestic building, so I'll click on this general domestic use, which is this. I'll not input roof load because this is not a roof slab, is a normal slab where people will be on. This is not at the roof level. At the roof level we have aluminium to cover our roof, so we are not having roof slab there. So I'll leave this roof road. Then coming to snow, this is African country, so there's no snow road here. And two, coming to lane load, we are not having adverse weather, so I'll not really include this lane load. So at this point, what I'll do now is I'll come and start inputting my slab. So I'll click on it. I'll also click. I'll also click. I'll also click. I'll also click. I'll click. I'll click. I'll click. I'll click. I'll click. Then I'll move. I'll click. I'll input slab, I'll input slab, I'll input slab. Remember, here is our staircase, so we will not input slab at this point. So after this, I'll just come and close this. Then next thing to do now is to hinge our members. Yes, hinge our members. Reason for hinging your members is mainly to save costs. Yes, remember I told you safety. Sorry, I said that safety is our priority. Then after safety, next thing is economy. If you do not hinge your member, that means your ProtaStructure will be providing more reinforcements on your members. Okay, let me explain. You know that summation. Okay, let me just explain this now. I'll explain using this beam. So for example, summation of moment. Okay, if I want to draw the bending moment diagram of this, look at it. It will go like this. From this point, it will go up like this. It will come down, go up because of this hugging moment, come down because of sagging moment, then terminate at this. Yes, so if you see now, it started from here because this is because the moment at this point is 0. Yes, that is the reason why we should hinge here, because if you do not hinge here, ProtaStructure will not know that the moment here is 0. Yes, and it will design, and to if it doesn't, if yeah, it will not know that the moment here is 0, and to it will design to counter the moment at this point, because it not tell it that the moment at this point is 0. So in process of design to counter the moment, what it means is that it will be providing more reinforcement at this point. Yeah, because of there is high moment, because you're not saying that the moment at this point is 0. Yes, if you can remember, summation of moment at any point is equal to 0. Yes, summation of moment at any point is equal to 0. That means the summation of moment here is equal to 0. Look at what I said, summation of moment. I did not say moment at a point. I said the summation. There is a moment here. Maybe the moment here is 30. That means the moment here that we will not be negative 30. If you not do 30 plus negative 30, you'll be having 0. So that is what I mean by summation of moment is equal to 0. So here I'm having negative 30, assuming, and here I'm having positive 30. So negative 30 plus 30, I'll not be having 0. So that is summation of moment at any point is equal to 0. So at this point, let me say I'm having 20 here. So I'm having 20. So you see, there is no moment at this. There is no moment here. There is no beam here. So there is no moment here. So that means what it means is that for summation of moment here to be equal to 0, that means the moment in this beam is equal to 0. So that's why you should tell ProtaStructure that here that the moment at this point is 0. So how will ProtaStructure know that is by you hinging it. And if you do not hinge it, ProtaStructure will design to counter that moment. For example, you know, we're having, okay, for example, look at this. Our bending moment diagram will go like this to this point. It will go like this upward. So the reason why we do provide reinforcement is to counter this moment at this bottom part. That's why we provide reinforcement. So if you not tell ProtaStructure that moment here is not 0, it will provide reinforcement to counter that moment. And in that case, you are no longer economical in your design. You are now wasting your client's money. So please, make sure you hinge your beam at any time whenever you are doing your design. Hinge your beam. So remember, if you are to hinge beam, we are going to hinge here and hinge here. We are not hinging here because summation of moment here is not equal to 0. We are not also hinging here because this is a continuous beam. So moment here is not 0, moment here is 0. Here we'll be having something like this. It will come down and go up again, come down. We're having hugging moment here, hugging moment here. So what I'll do is that I'll first of all, this one, both here and here will be 0 because this is a simply supported beam. So I'll hinge here and also hinge here. So what I'll do now is that I'll first of all hinge all the simply supported, because once it comes to simply supported, you'll be hinging both in IN, this is IN, and both in JN, this is JN. So I'll select all my simply supported beam and hinge both in I and JN. So this is a simply supported beam, and also this is a simply supported beam. Yes, this is also a simply supported beam, and this is also a simply supported beam. Okay, let's do the horizontal first. So this is okay, this is a simply supported beam, and these two, yeah, we are doing for the horizontals. Yeah, then I'm having, let's check again. This is not a simple, this is not, no, it's not a simply supported. I'm having this as a simply supported beam. This is not a simply supported beam. I'm having this as a simply supported beam. This is not, and I'm also having this as a simply supported beam. Yes, I'm also having this. Coming to this one, this vertical, yes, horizontal supported, simply supported. This is also a simply supported beam. Yeah, but it's having a point root acting on it at this point. So this is a simply supported beam. This is not a simply supported beam, and this is not a simply supported beam. This is not a simply supported beam. This is not a simply supported beam. Yeah, this is a simply supported beam. Yes, this is not a simply supported beam, and this is a simply supported beam, and also this is also a simply supported beam. So I think we have done all the simply supported. So I'll right click, then come to this bottom part that say update beam end condition. I'll now say both end hinge. So I'll now hinge both ends. So I'll click on this. I'll now click on apply to the selected beam. Click on it. So if you check now, let's escape. And if you check now, look at it. This thing means hinge. That means there is no moment at this point again. So ProtaStructure will not design to counter the moment. It will not design to counter any moment here again, because there's no moment here again. That means here will be normal bar. It will provide normal reinforcement for here. We will be able to save cost by doing this. So at this point again, next thing is that I would like to hinge the ones of I end. Remember, since if I'm hinging the one of I end again, I will not select this simply supported again. I will not select them again. So I want to hinge the ones of I end. So I'll click on this. So I'll hinge this I end. Let's do for this side first. So I'll not hinge, this is still IM, but I'll not hinge this again because I've already done it both ends. Yeah, because I've already done it for both ends. So if you hinge it again as I end, that means the one at this side will just go. So I'm having I end here. I'll also hold my control key and click on this I end. Yes, this is simple. I'm also having an I end here. This is simply supported. This is simply supported. I'm also having I end here. Then coming over to this side, simply supported. I'm having I end here. Let me click it. I'm having I end here. Yes, this is it. I'm also having I end here. This is it. I think my I end has finished. Then coming over to the vertical, this is it. I'm having I end at this point. This is simply supported. I'm having I end at this point. Then I'm also having I end at this point. I'm also having I end at this point. Then this is a continuous beam. I'm having I end at this point. This is a continuous beam. I'm having I end at this point. This is a simply supported. So I'll right click to update beam end condition. Look at it at hinge at left end. That's I end. I'll click on it, apply to the selected beam. So next thing now is to hinge the J ends. So let me do for this side first. This is my J end. So I'll click on it. I'll hinge here. So this is another J end. I'll hinge here. This is a simply supported. This is a simply supported. I think we are through with this now. Yeah, I'll come over to this point. This is a J end. I'll hinge here. Simply supported. Okay, this is a J end. I'll hinge here. And also this is a J end. I'll hinge here. And also this is simply supported. This is simply supported. And this is a J end. I'll hinge here. So we are done. We are through with all our horizontal. So let me go over to vertical. So I'm having this is a J end. So I'll hinge here. Hold your control key. So this is simply supported. This is also a J end. I'll hinge here. Yes. This is a simply supported beam. This one I'll hinge here because it's a J end. I'll also hinge here, J end. Then I will come and hinge here. It is a J end. I'll also hinge here. Is a J end. I'll hinge here. Is a J end. And this is a simply supported. So I'll right click to hinge all my J ends. Look at it, update beam end condition. I'll now say hinge. I'll now click on apply to the selected beam. So at this point, next thing to do is to input our wall load. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you. In inputting wall load, so let me escape. In inputting wall load, I want to input wall load. So I'll click on this beam, I'll right click, then click on this where is it? Edit load. I'll come and click on edit load. So you click on it. Now I'll come and click on wall load. I'll click on wall load because I want to apply wall. So once I click on wall load, this dialog box will appear. Yes, so this dialog box will appear. So I'll come over to this point and then select user define. Yes, user define wall load. Then I'll come, if you want to input doors and windows, you now use edit openings, but I don't want to input them. I want to design the as worst case. So I'll click on this. What is the wall unit weight? Wall unit weight. So once it comes to wall unit weight, you know we're using block wall of 225, that's 9 inches. So the unit weight of 9 inches block wall is 2.87. Yeah, that's the unit weight of 9 inches block wall. 2.87 kilo Newton per meter square. Then, but you know that once after placing that block wall, we'll plaster it. Yeah, that's sand and cement. That's mortar. We'll apply mortar to it. So we'll apply mortar both at the front and both at the end. And two, the unit weight of mortar is 0.3. Yeah, the unit weight of mortar 0.3. But we're going to apply mortar both at the front and also both at the back. So that means we are applying mortar twice. So that means we'll be having 0.3 plus 0.3. Therefore, the total unit weight will now be 0.3 plus 0.3 plus 2.87. That's the unit weight of the block wall. That means the total unit weight we'll be having is that if you do 0.6, that's 0.3 plus 0.3 plus 2.87, you'll be having 3.47. Yeah, 3.47. If you press it in your calculator, you'll be having 3.47. So this is the unit weight of our block wall. Then we'll come over. What is the height of our the height of our block wall? So if you come here, you see what H stands for. H stands for from the top of your slab to your beam depth, like below your beam. That's H, from the top of your slab to where your beam stopped. So the height of the story is 3 meters. Then you subtract your beam depth. You know, your beam depth here is now 300. Yeah, because after your slab, 450, 150 is slab, then 300 is now your drop down beam. So you now do that 3,000, that's 3 meters minus 300, that's 3,000 millimeter minus by 300 millimeter. The 300 is your drop down beam, which is this. So if you do it, you'll not be having 2.7. That's 2,700. Since this is in millimeter, we're using 2,700 because this is in millimeter. Yes, I hope you understand. Look at it. This H is from this H start and H end is from our slab to where our beam stopped, and our story height is 3 meters. So if you now do 3 meters minus by your beam depth, you now be having what? 2,700. So let's click on this one. If you see, that's our drop down beam. That's this D. Look at it. This start, our drop down beam is 300. Why our the remaining part from drop down beam to the floor is 2,700. So if you now do 2,700 plus 300, you now be having 3,000. So what is our block thickness? Is 225. That's the block thickness. That's the block thickness we are using. So don't click on insert, just come over to this point and click on this. Click on this. So the load has been applied. You now click on OK. So look at it. This is what we're having now. See, we have successfully applied this load. So what I will do now is that I'll copy this load. I'll click on it. Click on copy load. I'll copy load. Then I'll click on OK. Then I'll now apply it to all these beams. So I'll first of all come to this part. This is okay. Since I've copied, I'll come. Where is my beam? So this is my beam. So look at it. This is our beam 1. If you can see it, this is our beam 1. So I'll apply the load from here to, I'll hold my shift key to this point. Yes, let's wait for them to be selected. So if you see it's been selected, look at it from this. Remember, we have already applied it at beam 1, so there's no need of applying it again at beam 1. So from this point to this point. So this is our whole beam. I'll then you either click on paste load. You either click on paste load here, or you right click and then click on paste load, any of them. So I've successfully placed my beam load. But if you can remember, we are not having wall at all points. Yes, we are not having wall at all points. So let's go to our textural plan and know the places we are not having walls and the places we are having walls. So come over to our textural plan. So these are architectural plan. So we'll come over to this point to know the places where we are having what and the places where we are not having what. Okay, we are not having wall here. Yeah, there's no wall here, but I can decide to leave it any of them. Okay, in fact, we are even having wall all around. Yes, the only place I know that we're not having wall is just here. Yeah, this veranda. Yeah, this is not, there is no wall here, and also there is no wall here, but we can decide to leave it for worst condition, or you can decide to apply it. Yes, but let's just apply it, but you can decide to leave it here, but let's just apply it. So we'll come over to ProtaStructure. That means, hey, okay, that means we need to start creating a new grid line. Since, because we not import that grid line from AutoCAD, we need to start creating a new grid line. So okay, let me just leave it. Let me just design as the worst condition. But on your own, you can decide to offset this grid line, then remove the load. Yeah, you can decide to offset this grid line, and then you now delete this wall load and apply wall load to only the place where wall load is being acted upon. But I just want to leave it like this and design against worst condition. So let me come over to my 3D view and see what I have done so far. So this is my view. I will right click, then click on 3D physical model. So I'll click on it. Look at it, it's loading. Remember, you can get the architectural CAD file of this and practice on your own. Yes, they get the architectural CAD file and practice on your own, because practice makes perfect. So this is what we are having. This is what we are having. This is what we are having. So right now, next thing that we'll be doing now is to go and insert story. You know, this is a this is a 3 floor building. Yeah. So this is the first floor. We'll say insert 2 more floors. So next thing to do now is to what? Insert story. So I'll come over to my plan view. Once I come over to my plan view, I'll then come over to my building setout. Come over to building setout, then come over to story, then click on story, then click on insert story. So once I click on insert story, what is number of story I want to insert? 4. Don't worry, it's 4. You know we are designing for a 3-story residential building. So if I design 3-story, you insert 4. If you are designing for 5, you insert 6. So I'll then click on generate member from the selected story, and then the selected story is the story 1. Then I'll now say the story height should be 3000 millimeter. I'll then click on OK. So I'll allow it to generate story. So look at it, it's generating. Yeah, so this is what I have now. So let's come over to our 3D view. So come over to our 3D view, look at it. This is our first floor, second floor, and third floor. Then this is our roof beam. So look at it. ProtaStructure takes it that this is your story 1, story 2, story 3, and story 4. But we are taking this story 4 as our roof beam. So I'll come to our plan. So make sure you are in story 4. We are in story 4. So if you are looking at this, we don't need all this wall load in this story 4. So I'll come over to story 4, click on this triangle here, then come to my beam. Once I come to my beam, I'll select from this one and go to my this beam, hold my shift key, click on this, then I'll right click. Once I right click, a dialog box will appear. So let's wait for it. You now click on delete load, click on it, then click on OK. So look at it, our load has been deleted. Then next thing now, at this story 4, we don't need slab. We don't need this slab. We don't need all this slab because this is our roof level. Yeah, we don't need slab. So I'll come over to slab. Where am I having slab? So this is my slab. I'll click on this first slab. Okay, click on this first slab. Hold my shift key. Then click on the last slab. Everything has been selected. I'll then right click again, click on delete, and then click on see. It's only slab that is being selected. Then click on OK. So everything will be deleted. So this is what I'm having now. But if you can remember, the depth of this our beam is 450. Yeah, the depth of this our beam is 450. But I told you the minimum beam depth is what? 300. The reason why we used 450 here is because of the depth of the slab. Yes, because of slab depth. Remember, minimum beam depth 300 plus slab depth 150. If you add both of them, you'll not be having 450. But now there is no longer slab on top of this building. We are not having slab again on this building. So that means this 450 we are having here, we have to convert it back to 300, which is the minimum beam depth. Then if it fails, we not add. I will not increase the beam depth, but we'll take it back to 300. So I'll come over to my beam. I'm still under story 4. I'll come to my beam. Once you come to your beam, look, this is this. I will just then like click. Once I like click, I'll now click on RC beam table. RC, that's the first concrete beam table. I'll click on it. Once I click on it, this dialog box will appear. So this is my breadth, which is 225 by 225. Then coming to this depth, which is H, I'll now change it to 300. I'll then come and click on this pencil icon, then change it to 300. Then I'll change it to 300, which is 300. So this is 300. I'll then click on OK. So if you see now, let's ahead, it has been converted to 300. I'll then click on close. Yes, look at it. If you see, it's no longer the same depth with this. Look at it. Are you seeing the difference? Look at this and this. You see the difference. So right now we have successfully converted this to 300. So next thing that we'll be doing now is we want to apply our roof load. Yeah, remember we'll be using parapet in this building. This building will be having parapet. We'll be having parapet around this roof for beauty. So we'll be applying our parapet load. So in applying that parapet load, I'll come over to my plan view. So I would like to use slab, cantilever slab as my parapet. Yes, I would like to use cantilever slab as my parapet. So I'll come over to modeling, come over to slab. Then I'll pick, some people will use wall load, so you can use wall load, you can use, but me I want to use parapet, I want to use slab, this cantilever slab. So cantilever stands for this number 12. I'll click on number 12. Then what should be my depth? I would like to leave it as this 120. I would like to leave it at 120. Then so what should be the length of my cantilever? I'm using 400. Yeah, I'm using 400 as the length of my cantilever. Then once I have this now, I'll come over to this point. I would like to apply cantilever from here to here. Yes, I also like to have cantilever from here to here. This is what I'm having. This is what I'm using as my parapet load. Yes, from here to here. I'll just do it around this building. Then from here to here. Then from here to here. And also from this point to this point. I'll take it out from this point. Okay. Let me just do it column by column. Then let's wait for it. Let's wait for it. From here to here. Let's wait for it. Also from this point to this point, let's bring it down. Then from here to here, let's bring it out. From this point to this point, let's bring it out. Then this is what we are still having. Let's wait for it. Let's wait for it. Let's wait for it. Then we're having from here to here. Remember, you can get the CAD file of this architectural plan and then practice on your own, because practice makes what perfect. Practice makes what perfect. The more you get this, the more you do this, the more it becomes what part of you. Yeah, we all learn by practicing. Yes, the more you do, the more you become part of it. Because the more you do, the more it become part of you. So get the CAD file and practice on your own, because it will really help you. So I'll take it out. This I'll do from here to. So let me stop here. Yeah, from here to here, I'm having this. I'll do also from here to here, I'm having this. I'll also do from this point to this point, I'm having this. Yes, and also from here to here, I'm having this. And then from this point to this point, I'm having this. So this is what I'm having, and I've applied my parapet load. Then next thing you do that, you can come and delete some of this beam, because this is the last floor. This is the last floor. And two, we'll be having our crosses running across this beam. So any beam that you feel that is not really necessary, you can delete it. Yeah, to save cost. Any beam that you feel that is not really necessary, you can delete it. But my own, I don't think I'll be deleting any. I'll just leave it like this. So right now we have applied our parapet tool. So let's go over to our 3D view. So this is what we are having now. This is what we are having. Okay, let me turn off everything. I'll come to display, come to layer, come to turn off axis, turn off ghost axis, turn off plane definition, and turn off my text. So this is what I'm having right now. So if you can see, this is what I'm having. So we have successfully modeled this. Yeah, we are through with our modeling. We have successfully modeled this with our parapet road. Yes, look at our parapet road. We have our parapet road intact. Next thing is to edit story. I'll come over and edit story. You see what I mean by edit story. Come over to this point. Come over to my story. Come over to this point. Then click on edit story. Look at it. Edit story. Yeah, you see what we are going to do there. So in terms of edit story, in case none of them is in its correct height, look at it. This is 3,000, 3,000, 3,000, 3,000. So it's okay. This one is the height. From here is 3,000. This is 6,000, 9,000, 12 meters. So if you can see, we're having 12 meters. So our story height is above 10 meters. That means we must apply wind load. This is just the bearing. So once it comes to this load, imposed load reduction, this imposed load reduction is about high-rise building. It's mainly about high-rise building. So if you want to apply it, we apply it from this point, but it's not applicable in this video, because this is just a 3-story building. It's all this story, like let me say 8, 9, 10 and above. You can apply this load reduction, because not all the time that all the floors will be in use. That's why we do apply this load reduction. So coming over to this point, so what will be our foundation depth? Since we are going with beam raft foundation, we'll be using the foundation depth of 100. So 1 meter. Yeah, 1 meter. Then if it fails, we will not increase, because we are going for beam raft foundation. Then what is our first story bottom level? First story bottom level is 450. Yeah, 450. Look at it. Once you click on 450, you see. Okay, yeah, it will be 450. See, the story height has been increased. Look at it, has been added to this 450. What do you mean by first story bottom level? Like the difference between your ground soil and your finished floor level. The difference between your ground soil and your finished floor level. Then after applying all these settings, I'll then come over and click on what? Okay. Then that's it. This and the previous process will not be undone. I'll click on yes. So I've applied this. Then after this, I'll now come over to my plan view. So I'll turn back everything. Turn back my axis, my ghost axis, my plane definition, and also my test. So everything has been turned on. I would like to come over to story 1. Next thing we'll be doing now is to carry out our building model check. So to carry out our building model check, we'll come to this tab, review. Then under review, we'll click on building model check. Then once we come to this place, we'll click on start. So let's allow it. Yes. Okay, that means we're having some errors. If you can see, yeah, we're having some errors. So right now the number of errors they are 6. So let's go up and see the errors that we're having. They say that story 4, story 4, story 4, all of them are from story 4. And they say that slab 4 that slab 6, that's slab number 6, slab number 10, and slab number 16, slab number 17, that they have a very small area. Yeah, that I should check the slab geometry. So let me just click on close and let's come over to story 4. Yeah, let's come over to story 4. So coming over to story 4, you see that it's all this slab, like this our parapet slab, that they are telling us that we have a very small area. So in this case, we cannot do anything to this error. So that means we are going to leave it like this. Yeah, they said that this is a very small area. Yes, it's true, this is a very small area, but we cannot do anything to this area. So we are going to leave this error like that and continue on with our analysis in our next video. So coming over to this story now, look at, if you see this beam rabbet is inside this beam, but I would like it to be outside. Yes, I would like it to be outside. And also this column dimension, this C1 225 by 225, I would like to be having just something like C1 and not really 225 by 225. Or okay, in which I can leave this one, but this being label, I would like to bring it out. So I'll come over to my setting, Once I'm in my setting, let's allow it to open. Then I'll come over to label. Then once I come over to label, this is the bin label. So I'll take it outside. Look at it, it's not outside. Then in that one, if you want to hide that column section 225 by 225, you click on hide. But let's just leave it because I know some of our column at the ground floor might fail. So some of them might fail. We'll increase their size because I already know, because this is a 3-story residential building, and two, I spaced them well. I spaced my column well. So I know that some of them will require higher sizing, that's higher dimension. So that's why I'll still leave it. So I'll be seeing that. So I'll know what I'm doing. So I'll click on OK. So look at it, it's not outside. So once I'm through with this thing now, next thing I'll do is I'll arrange my beam serially. For example, look at, I'm having beam 1, this one should be 2, 3, 4, but look at it, I'm having 7. Look at it, 7, 7, 8, and the 9. So I should arrange my beam serially so that once it comes to detailing, I will not waste time in detailing. So to arrange your beam serially, I'll come over to review, come to relabel members. I'll come over to relabel members. Then I'll click on, since I've done for axis before, I'll click on story, just click on everything. I'll just click on everything and then come and click on OK. So you see that everything will automatically be relabel. So look at it, 2, 3, 4, 5. If you come down, 5. Okay, 5. Maybe 5. Okay, 5. Then you come to this one, 6, 7. Then like that, 8, 9. So like that, then what? You label your axis. Then next thing, once it comes to analysis, we will now add our wind load. Don't forget, you can still get the CAD file of this architectural plan and practice on your own, so you get to learn everything and it will become part of you the more you practice. And if you found this video helpful, please like the video. Also, you can share it in your class group or in your work group so that more people get to see and more people will learn alongside you.
Are you a civil engineer? Let me ask you a question. What if in just few days from now, you can pick up any architectural plan, confidently carry out its full structural design and detailing and start earning from it? Sounds unreal, right? Stay with me because I'm about to show you exactly how. I created a 10 days intensive structural design and detailing masterclass to show you step by step how real structural design is done in practice, and this course is designed to last for 10 days. Before I show you what you are going to learn, this is the architectural plan we'll be working with, and we will carry out its structural design and detailing. Day 1 of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about path-based footing detailing. Day 6, column detailing. Day 7, beam detailing. Day 8, slab detailing, and you will understand the governing principles in slab reinforcement, that is how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10, you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan. And finally, you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally, access to our online engineering community where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
This video will all be about analysis and design. We have done the general arrangement drawing, that's structural framing of this three-story residential building, and from there we're able to expose the governing principle in both column placement, beam placement, and also slab placement. And in our last video, we did the modeling of this video. We were able to come to this. We added this parapet road and many things that we did in the modeling. So right now, this video is all about analysis and design. So we are going to analyze this building and also design this building. So coming over to analysis, we'll come to this analysis tab. We'll click on analysis, then we'll click on building analysis. Here we are going to click on building analysis. So a dialog box will appear. Let's wait for it. So this is the dialog box that appears. If you can remember, we said that once our building is more than 10 meters, once the height is more than 10 meters, we are going to apply wind load. So let's apply our wind load. So I'll click on wind and story load. I'll come to this place that says wind load calculator. So I'll click on it, wind load calculator. So let's allow it to open. So at this point, look at what they're asking me. They're asking for basic wind speed. So basic wind speed in my area where I'm designing this building, the wind speed there is 30 meters per second. Yes, but if you want to get the wind speed of your area, you'll browse about the wind speed of that location in the last 5 years. Yes, once you get the wind speed of that location in the last 5 years, then you now take the average. Yes, don't browse, don't go beyond, don't go and be doing in the last 20 years or in the last 30 years, because you know that once it comes to last 30 years, maybe that time the number of buildings that are in that area is few. That means the wind speed then will be very high. But maybe recently they have started the development has started entering that area, so that means there are more buildings now. That means those buildings will be restricting wind, like it will be restricting the wind speed. So that's why you should just take between from now to last 5 years. So coming over to minimum wind pressure, this is the minimum wind speed. So you just leave this one as default. Since you don't know the minimum wind speed in that your area, you can never dictate, or just leave it as 0.5, because this is just the minimum. So this one is a primary wind angle. So I also advise that you leave it at 0, because you don't know the angle the wind is coming from. You don't know whether it's from 90 degrees, 30 degrees, or 40 degrees. You don't know the angle. So since you don't know the angle of your wind, but if you know the angle, you can put over. Me, I'll advise leave this as default. So coming over to this place, like from this high hill and also to this low bracket, I'll advise you to leave it at default, because look at it, everything here is all about here. So if you see, S stands for the distance of the hill to look at it. S is the horizontal distance of the site from the top of the crest. That's this hill now. The distance from this point, that's the top of this crest, to where your building is located. But if you can get it, you can input it. But if you don't know it, you can just leave it as default. Even D is just, look at the actual length of the downward slope in the wind direction. That's from this downward slope in from to your to where your building is located. But if you don't also know it, you can leave it as default. That's why I'll advise leave this area as default. Then total building height has been calculated by the software, which is on 12 meters, is above 10 meters. So that's why we are adding wind. That's why we are adding the wind speed. So this one is hill type. So I'll advise you to leave it as this script. Yeah, leave it like this. Then upward or downward wind, leave it as upward wind. Yeah, leave it as upwind. Reason why is because if you take downwind. That means downwind will be giving more stability to that structure. Yes, because once a wind is being applied on a building downward, that means it's sending it down to the soil. Yeah, and once it's pulling it down to the soil, that means it's giving that building more stability. But upward wind, it will try to pull it away from the soil, will try to raise it up. That means the stability of the building is at risk. So I'll advise you to leave it as well, upward wind. Then these ones, you can leave these ones at default. Then at this point, terrain category, you can just come and choose your terrain category. It depends. This one for sea coastal, if your building is located near the sea. But remember, if you choose this, that means the software automatically increase the wind coming to your structure. Yeah, because if your building is located near the sea, that means there will be high wind pressure in that area. So you just choose the one that best describe where your building will be located. So in my own is this category 4, which is area in which at least 15% of the surface is covered by building and the average height exceeds 15 meters. So this best category that describe where my building is located. So I'll click on it and then come over to this one and click on OK. So right now we have applied our wind road. So at this point, look at building category. It depends. If you are designing for steel, you can choose this. If it's composite, it means that's where concrete and steel combined together. So anyone you are doing, but in this case, this is a 3-story residential building and is a reinforced concrete structure. So at this point, I'll just come and click on apply. So I've applied my wind road. I'll click on OK. So at this point, next thing is to come and choose my material. So I'll come over to my material, then I'll click on this, which is this, to choose my concrete grade. So I'll come the concrete grade I would like to use is what, grade 20. This is grade 25, and that's compressive strength. So I'll prefer to use grade 20, which is this. I'll click on apply to all members and then click on OK. Then if you see everything has changed, then come over to my steel grade. The steel grade I would like to use is this grade 460 type 2. Yes, I'll click on grade 460 type 2. Then in case, look at this rebar symbol. If you don't want it to be in T, for example, if you want Y, you can input Y here. If you want, so it depends on the one you want, but me, I prefer T, so I'll leave it at what, T. So look at 460 type 2. So I'll come and click on apply to all members. Then look at rebar diameter. You come and click on edit to choose your rebar diameter. So coming over to column, I would like my column to be this Y16. Yes, then I would not like to check any other one again. If 4Y16 fails, it should give me 6Y16. I don't want Y20. Yeah, because I know my client will not like Y20, so there's no need of me applying Y20, because I know that this Y16, if it fails, it will just increase the number maybe to 4, 6 or so. Then coming to shear wall, I don't have any shear wall, so I leave it. Then coming to beam, I will still repeat the same, only Y16. If it fails, it should increase the number. Like if 2Y16 fails, it should take it to 4 or 3. Yes, that's what I prefer. Then coming over to slab, I also prefer Y12 in slab, only Y12. Yes, I don't want any other slab. Then coming over to lip slab, I don't have any lip slab in this. This is not, I designed with a solid slab, not lip slab, so I'll leave this as a blank. I'll leave it blank. Then coming over to foundation, remember this is a beam lab foundation, so we are using Y16. Yes, me, I don't want Y20. I don't want this, and don't also want this. So we are leaving it as what, Y16. Yeah, because this is we are working with beam raft foundation. Then coming over to my ring, I would like it to be 10, so I will deselect the rest. Then coming over to this one is for shear wall, that's the shear wall. So since I don't have any shear wall in this building, I'll just leave it as default and then click on OK. So if you see now, I've clicked on this, I'll then come over and click on OK. If you see everything has been adjusted, then I'll come over to my foundation. So coming over to my foundation, the foundation type, I'll click on my concrete grade, which is still, I would like to use this compressive strength of 420. I'll click on apply to all members and then click on OK. Then come over to my steel grade, I would like to use 460. Yes, I'll leave this. If you check your this thing, that means the previous settings we did is still intact. Look at it, Y16. So I'll just come and click on OK, then click on apply to all members and then come over to this point and also click on OK. Yeah, okay, this one I'll come and also select 460. That's for my ring. I'll select 460, click on apply to all member and click on OK. Yeah, this one is for my rings. Then coming over to the soil type, and you know the bearing capacity of our soil is 75. Yes, the bearing capacity of our soil is 75. That's why we are going for a beam raft foundation, and the soil type we're having there is silt, not sand. So it's silt. I'll come over to this point and then click on OK. So once I'm through with all this, I'll also come over to this point and click on OK. Then once I'm through with all this, the next thing I'll do now is to go to analysis and design. In our previous videos, we did the building model check. So right now we're going into analysis and design. So I'll click on it. Let's allow it to open. So this is where we are now. Some people would like to do the building analysis first, then then after they will now do the design. But in this video, I would like to do both the building analysis and the design at once. It all depends on you. So in this red bar, I will advise you, if it is your first time of carrying out the design of that project, if it's your first time, check this red bar. But if it's that you have done your interactive design, you have designed it before and you have done your interactive design, please don't click on red bar, because if you click on red bar, everything you have done in your interactive design will just scatter. They will scatter it for you. They will reselect all of them for you. So if you have not done your interactive design, click on the select bar. But if you have done your interactive design, please don't click on the select bar. So at this point, what I'll do is I'll click on building analysis. So we'll allow to analyze our building. So look at it, it's analyzing our building now, and after this, it will design our building. So while we are waiting for this to design and to analyze and design our building, remember we went from the structural framing to modeling, and now we are currently at analysis and design phase. And the link to all those videos is in this video description. Don't forget, you can get the CAD file. Yes, the CAD file of this is available. You can get it and also practice on your own, because practice makes perfect. The more you practice this, the more you are able to learn. Now they are doing our column reinforcement design. So the more you practice this, the more you get to know, or the more you get to know it. If you watch 100 videos and another person just watch only 10 videos and practice those 10 videos that he watched, that I bet you and I promise you that person will be far better than you. So practice makes perfect. Make sure you practice, don't just watch. So now is in beam design. So let's allow it to design our beam for us. So as we are waiting for it. Make sure you practice. Make sure you like this video. Yeah, if you are also finding this video helpful, please do also swear to like the video. Don't just like the video, you can as well share the video in your class group if you're a student, or in your work group if you're practicing engineer. So you can do well to share the video so that more people will get to see, and also more people will get to learn alongside you. Yes, don't learn alone. Let other people learn with you together. So now it's still designing. It's currently in story 2. Look at it, story 2. Now they have entered story 3. So we are in story 3. Very soon now the building design will be over. So we are currently at story 4. Yeah, we is designing the story 4 beams. So if you look at it, it's moving. So we are almost through with the design. Yes, we are through with the design. So this is it.
If your relative story drift fails, what it means is that you have to increase the size of your column, or you increase the number of your column. That's if you are seeing bad here. That's if it fails in direction 1 and in direction 2. What it means is that you go and increase the number of your column, or you increase the size of your column, one of them. So after seeing this, the next thing to do is I'll come and click on OK.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group, so that more people will get to see this and they will also learn alongside you.
So I'm through with my design. If you come over to this building analysis, look at it. It has been checked, it has been marked blue. That means I've designed this building. So I'll come over to display. Once I come over to display, this is visual interrogation. I'll click on it, then I'll come over to design status, then click on my design status, then click on OK. So with this now, I'll see the ones that are failing and the ones that are passing. So if you can see, I have some of my columns failing. Yeah, some of my columns, they are failing. Yeah, this column is also failing. This column in story 2 is also failing. Then almost all my beams they passed, right? So almost all of them they pass. But even though that your beams they are passing, even if your columns and your beams, if they are passing, please make sure you do your interactive design. Make sure it is a compulsory something, not if it passes you leave it. So to do my interactive design, I'll come over to my plan view, then I'll turn on my visual interrogation for plan view 2. I'll click on this, then come over to visual interrogate design status and click on this. Yes, okay, I forgot to say something. Look at it. Green means that it has been designed, while white means it has not yet been designed. For example, look at our slabs. They are white in color, meaning that we have not yet designed them. Yes, orange is just expired analysis. Why LED means failure. Look at this one's on LED, they mean failure. So I'll come over to my plan view, I'll come over to my story one and start doing my interactive design one after the other. So but I'll not do interactive design for everything. I'll do something like 5 of the beams, then I'll come over to column and do for column 2. Then on your own, if you get the CAD file, you can now do the interactive design of all of them once you get the CAD file. Remember, the link to the CAD file is in this video description. You can get it there. So I'll click on this beam. Once I click on, I'll right click, then click on section design. Then I'll click on section design. So this is what I'm having right now. Yes, they're giving me 3y16 and 2y16, 2y16. So this is okay for me, but I would like to rearrange this beam. I would not like to have it like this, even though I'm still having 3y16 here. So I'll escape, come over to this one, click on this. Look at, I'll come over to extend light. I'll come extend right to lap. I'll click on this and also come over to this part and click on, I'll click on this, then click on extend left to lap. I'll click on this. So once it has lap, I'll come over to this point and increase it to I'll increase it by one number. So what I'm having here total is what, 3y16. Yes, because this is 2y16. So 2y16 is passing here, then plus this one is still 3y16. So it will stay the same thing. But if you arrange it like this, your detailed drawing will be arranged where, yeah, if you leave it like this, your detailed drawing, the arrangement will be more accurate. So I'll just explain to you the failings in ProtaStructure and how to solve them. Yeah, we have about 5 force failing in ProtaStructure. First, your beam can fail in bending. Yeah, bending means that you have not yet provided enough reinforcement to counter the bending moment. For example, assuming I'm having one reinforcement here. So okay, assuming I'm having one, okay, let me just, for example, assuming I'm having, so let me increase this one back to 2. Yes, assuming I'm having one reinforcement here. Look at, it is failing here, meaning that it is failing in bending, like in moments, not bending, it's failing in moments. Yeah, that means I need to provide more reinforcement to counter the moment acting on this beam, because you know this, the bending moment diagram is like this, then it will go up, come down again, then terminate at 0. So to provide more moment, to provide more reinforcement to counter it, you increase it. Yeah, you keep on increase it till it passes. Let's go over to the bending moment diagram. So this is the bending moment diagram. So let's click on it. So let's wait for it to appear. So look at it. If you see there is a hugging moment here, this is sagging moment. This is the reason why I say you should always hinge your beam members. Look at it. It's starting from 0. But if I do not hinge this beam member now, it is here will not start from 0. Like I'll be having moment here, and ProtaStructure will design to counter that moment. That's as me, I do not hinge my beam member being modeling. Yeah, I'll be having this moment diagram now will look like this. It will come like this, then it will not go up, come down. That means there will be a moment here, and ProtaStructure will provide reinforcement to counter that moment. That's why I'm having 3y16 here, because of this moment here. So ProtaStructure provided bars, it provided reinforcement to counter this moment. Yes, it's correct. So that's why you must hinge your beam members to avoid over design. Yeah, not to waste your client's money, because first is safety. Once it comes to design, first safety. After safety, it comes to economy. So you have to be economical in your design, so you not be waste your client's money anyhow. So come over to this point. So because of this high moment, that's why we are having 3y16. So you keep on increasing this reinforcement till it passes. Then it can fail in shear. That's right. This, look at it. It can fail in shear. Fail means right, what I call sudden failure or sudden, just like sliding. Yeah, that's shear, just like sliding. So it can also fail in shear. So if it fail in shear, that means it will be failing here. You'll be seeing this thing in like here. Let me say, okay, it's just I cannot increase this again. But if it fails in fear, if it fails in shear, you come and decrease the spacing of your reinforcement. Yes, you come and decrease the spacing of your reinforcement. But if you keep on decreasing the spacing and it keeps on failing, you now come over to this point, to this beam, and then increase your beam depth. Yes, and increase your beam depth. So I'll come over to my rebar because it's not failing in shear. So okay, another failure that I can have is, for example, look at another failure. Look at this, another failure. For example, yes, if here is red in color, this is another failure. So if here is red in color, what you will do is that make sure it is not less than 20 millimeter. Yes, because the size of our coarse aggregate is 3/4. Yes, 3/4. That means if that's our gravel, our coarse aggregate is our gravel. If the size is 3/4 and that 3/4 is 20 millimeter, so make sure, because this is the spacing between your rebars. Okay, let's come over to detailed drawing. So I will explain this in very well, so you understand. So let's wait for it to appear. Detailed drawing. Let's wait for it to appear. So look at it. So assuming that spacing, what it means, lead bar, for example, that one I'm seeing 18. What it means that difference between here to here. Okay, wait, let me increase this so you understand it. Wait, let me just increase this. Let me just take it to 5. Yes, let me take it to 5. If you see it's failing here, it's 18. So let me now explain it so you understand it. So let's wait for it to appear. So look at it. Look at what it means. What it means that the spacing between here and here is 18 millimeters. Yes, the spacing between this bar and this bar is 18 millimeters. So what do you ensure that is not less than 20 millimeters, because our coarse aggregate is 20 millimeters. That's 3/4. That's our gravel is 20 millimeters. So if it is less than 20 millimeters, that means your coarse aggregates will not be able to pass through this reinforcement. Yeah, so that's why I say ensure that it's less than it is not less than 20 meters. But if it is above 20 millimeters, even though it's showing red, you can leave it because your coarse aggregate will be able to pass through. So I'll come over and exist this. So I think I've explained all the whole failures. Okay, yeah, there is also another failure. Another failure is the diffraction failure. Yes, diffraction failure. Where is diffraction? Look at it, diffraction shake. So assuming is failing here, this is diffraction shake. Assuming is failing, let me also decrease this. So assuming it's failing in this deflection, what you will do once it is failing in deflection, what you do is that you increase your beam depth. You come over to this point and increase your beam depth. That's if it is failing in deflection. In deflection is a must that you must increase the beam depth. Okay, what does it mean for a beam member to fail in deflection? A beam member failing in deflection doesn't necessarily mean that structure will collapse. No, it won't collapse because you have provided reinforcement to counter the moment. Is when you do not provide enough reinforcement to counter the moment, that is when your beam member will collapse. But if it fails in deflection, what it means is that the beam will be able to carry the load, but while carrying that load, it will deflate. Yes, and to remember, if it deflates, it will no longer be aesthetically pleasing because once it deflates, it will now cause cracks on your block wall. And once your block wall start cracking, that means I say they will take you like one nonsense engineer did the job. Yeah, so make sure your beam do not fail in deflection. Once it fails in deflection, please increase your beam depth because it will cause the beam to deflate while carrying the load, and that deflection will cause cracks on your block wall, but the beam will not fail, but it will cause crack on your block wall. That means your structure will no longer be that beautiful again. Yeah, because people will be seeing cracks on the block wall. So with this, I think I'm through with this. I've explained every failure in beam. Yeah, so I'll come and click on OK. So that's why, remember, if you are finding this video helpful, you can equally subscribe to this channel. Not just subscribe, you can share this video. Yes, if you're a student, you can share it to your classmates so that they also watch and learn. Don't learn alone. If you're working engineer, that's a practicing engineer, you can share it in your work group. Don't just learn alone. So with this now, let's come and shake this beam. Yeah, but in this beam now, I will be fast because I'll explain everything I need to explain. So look at it, 2x16, 2x16. So everything is okay since I'm having 2x16. Let me also come over and shake this beam. I'll right click, then click on section design. Look at it, okay, 3y16. Remember, I told you during our chrome placement that we might be having 3y16 here. So it's okay. Yes, okay. There's also another thing I forgot to mention. Make sure that this is the area of steel provided. So this is the area of steel required. Why this is the area of steel provided. So make sure that the area of steel provided is not less than 100 millimeters. Reason is because I'm located in an African country. Yes, and in this African country, they tamper with quality. Yeah. All this company, all this production company, they are trying to make profit from their product. Yeah, so our Y16, that's our reinforcement Y16, it is no longer Y16. If you go to the market now, that Y16 will be something like, because me, I'm based in Nigeria, and if I go to market, my Y16 will be something like Y14, Y15, or even Y13. None of them will be up to Y16. And also we use the yield strength of 460. So if I also go to market, I'm sure that those reinforcement, their yield strength is not up to even 430. So to counter those losses, that's why we ensure that our area of steel provided is at least 100 millimeter. It is not below 100 millimeter. If it is below 100 millimeter, please increase your reinforcement to prevent building collapse. Yeah, to prevent it will be a shame that you finish designing your structure and that building collapse because of you ignore all these small errors. Yeah, so make sure here is above 100. But if you're in all these European countries, South Africa, where they don't tamper with quality, even if you're getting 50, leave it like that. Even if you're getting 30, leave it like that. Yes, because your country, they don't tamper with quality. But if you're in all this African country where quality is being tampered with, please make sure it is above 100. So look at what this thing means. This is the area of steel required. And then look at this thing means that we provided SS, that we provided 2830 SS area of steel, because this is the amount required. Then we provided SS. But the thing is that if you decrease this now, if you decrease this to 2, it will start failing. That means it is failing because I've not yet provided enough area of steel. Like I still have to provide up to 4 to match this. So if I now increase it, that means I'm not providing SS, which is okay. I hope you are understanding and you are gaining a lot from this video. So I'll just shake one more beam, and then move over to Chrome to prevent so that this video will not be that lengthy. So I will come and check, okay, let me check this column, let me check this beam. I'll then click on section design. So this is what I'm having, 2x16. So this is less than 100. It is less than 100. Please increase it to prevent building collapse. So I'll come and click on okay. So right now we'll be going over to our column. So I'll escape. So coming over to our column, I'll click on it again, then likely click on section design. Yes, section design. Let's wait for dialog box to appear. So this is what we're having. So if you see, okay, let's click on interactive design. So if you can see, it is failing. Look at it, still ratio limit exceeded. So what we'll do in this case, remember in our structural framing, I told you that most of our column will be failing. Yes, if you have not watched that structural framing, please go and watch it, because I really explained a lot in that structural framing. I explained the governing principles in column placement, beam placement, and also slab placement. I also told you that limit the point load acting on your beam to avoid excessive moment on that beam. Yes, I explained a lot. So if you have not watched the video on structural framing, please go and watch it. So right now, this is what we're having now. So what it means that I have to increase the reinforcement, I have to increase the dimension of this column. So I'll write to go by 300. I'll click on update. So this is what I'm having. I'll then come over to interactive design. So I'm having 4y16. But there is a but. Let me just show you something. Look at it here. It's failing in slenderness. Yes, this column now is failing in slenderness. Let me explain what slenderness. What if a column fails in slenderness? It doesn't really mean that that column will not really carry that load. No, that's not what it means. But it means that it will really bend a little bit while carrying the load. Yes, but I could have increased it. Okay, let me click on okay. Let me just increase. Let me make here 300, and then make here. Let me make it. Let me say 800. Okay, let me say 500. You know, for example, this column should fail. So let me click on update, reselect bar, and then click on interactive design. And so if you see, even upon that 300 by 500, this column is still failing in slenderness. So slenderness is just a ratio of square. Like it means that your building should be more of a square for that column not to fail in slenderness. And also remember, okay, let me explain something. Column fails in two methods. We have two types of column. We have a short column and a long column. A short column fails by crushing. That's squashing. It's just like as if you just crush something or squash something. Why a long column fails by buckling, and two, it is from that buckling, that long column, that will got slenderness ratio. So this column now failing in slenderness means that you should increase the size of that column. But remember, I'm trying for this thing to align with the block wall. Yeah, I'm trying to I want my column to suit with my block wall. So even though this thing is failing in slenderness, it doesn't mean that your column, it doesn't mean that your structure will fail. It's just that your column will buckle a little bit while carrying the load, but it doesn't mean that it will fail. Yes, so since, okay, let me click on okay. Since I'm having even 300 by 500 is failing, that means I cannot really do anything about it. It's only when something like I have something like, let me say 500 here, that it will start passing, because it will be more of a square. Yes, let me click on the select and then click on interactive design. It will not be more of a square. Look at it, it's not passing. But I would like to use at least a size of 225, a size of minimum 250. I'll just come and click on okay. So I would like here to be 300. I don't know whether you understand what I'm saying. Then why here? Let me choose let me just choose 250, and then click on update, then click on the select bar, and then click on OK. So if you can see, it is still failing in slenderness. Yes, it is still failing in slenderness. So I just want you to understand something. So what I'll just do is that I'll still leave it in 225 by 225. My building will not collapse. Yes, it won't collapse, but it's just like the column might just tilt a bit, because okay, let me just click on update and then click on the select bar, click on interactive design. So if you see, it is 1.2 greater than 1, so it's just 0.2. It doesn't mean that it will, the buckling or the bending will not be that visible to sight. Yes, is as me I'm having something like 4 greater than 1, 5 greater than 1. That means that buckling will be visible to the eyes. But in this case, it is very small, which is 1.2 greater than 1. That buckling will not be visible to the eyes, but it will buckle a little bit. It doesn't mean that the column will fail. No, the building will not collapse. It's just that it will carry the load coming to it while buckling, because this is a long column. Because I told you once it comes to long column, that's when you have slenderness ratio. So it will buckle while carrying the load, but the buckling is very minimal. So that's why I'll agree to use 225 by 300 size of column. I don't know whether you understood what I explained. Yes, so these are the engineering principle behind the design that we'll do. We don't just assume values. Yes, so I'll just come and click on Okay. Yes. Okay. They're asking me the following analysis result will be invalid if you proceed. That's the building analysis result will be invalid. I'll click on no. It should not be invalid. So what I'll do now is that I'll right click. I'll right click. Then click on update still bar. Update still bar. So look at it. It has been updated. Yes. So I'll do few more columns. Then continue. Do few more columns. Then I will now end it. You can now get the cat file and practice on your own and do all of them, because the more you do this thing, the more you get to learn. Let me tell you, even if you watch 100 videos and practice none, and another person just watch only 10 and practice those 10, I bet you that person that practiced 10 will be far better than the person that watched 100 without practicing any. So you can get the cat file of this video using the link in this video description. You can get it. It's very cheap. Yeah, you can get it and practice on your own, because practice makes perfect. Remember, consistency beats intensity, and also be consistent in your practice. So yeah, okay, wait, I want to check something. I forgot to check something. Okay, this is the column I'm going for. So I'll like click again, click on section design. Then I'll come over to this point and increase it to 300. So 300. I'll click on update. So this one I'm having. I'll click on reselect bar and then click on interactive design. So I'm having this 4x16. I'll click on OK. So come. I'll say no again. Once I say no, I'll then like click on update still bar. So this is what I'm having. So I'll come over. Okay, look at this one is failing. This column is failing again. I'll like click on section design. Remember, I will not do all of them. Maybe after this, I'll do 2 more and then stop. Then what I'll do is that I'll come here, increase this one to 300. Click on update. If you see now I'm increasing this one to 300, this side 300. I'll show you the reason why I increase it to 300. Click on select bar, click on interactive design. So I'm having this. Okay, I'm having 8x16. So I'll click on OK. 8x16. So I'm okay with this. So I'll click on OK. So I'll still click on no. Yes, I'll still click on no. I'll escape. Then I click on update still bar. So look at it, it's been updated. But if you see, I'm having small offset outward. So doing my detailing, I'll move this column inwards. Yeah, I'll move it inside so it will align with the wall, or it will flush with the wall. So if you are also this one, I'll be getting the same thing. I'll be getting the same thing. Yes, I'll be getting the same thing. I'll still be getting that 8x16. Look at it. I'll do it 300. Update interactive design. Then I'm having it. Look at it to be 8x16. It will be different thing. Yes, I'll click on OK. Then click on no. Then I'll escape. Right click. Then click on update still bar. Reason why I'm still having 8x16. You know, this side and this side, they are the same thing. So it is the same load that this column is carrying, that this load is also carrying, that this column is also carrying. Remember, once it comes to detailing, I want to tell you whether this column should be positioned like this, or it should be like this. Yeah, once it comes to detailing. So make sure you watch our detailing video, because I'll be explaining it. Yes, you know, here I just made it I made it to be like this, any of them. Yeah, but in detailing, I will tell you whether should it be like this, or I should be having it like this. Yeah, once it comes to detailing, that's when I'll explain this. So let me do one more column. Okay, let me do one of the perimeter column. So I'll right click on update still over section design. Let's wait for it. So this is what I'm having: 2y16, 4y16. So it's okay. I don't need to check more again. So if you see, let me tell you something. All our perimeter columns, they will be 2y16 they will be 4y16. Yes. Do you know why they are 4y16? Because they are carrying a lesser load. Okay. Let me go over to display. Let me come over to this post and show you something. Look at it. I'm having I'll click on building analysis model, building analytical model. Let's wait for it to appear. So it's ready. Remember, you can get the CAD file. Remember, if you are finding this video helpful, please share. You can share to your friends, your classmates, and everybody, so people will get to learn, not just only you. So this is what I'm having right now. So I'll come to solid model. Let me explain something to you. Why those, okay, if you see like this, okay, the ones on blue means that the force coming to them is very high. Then blue means that it is carrying a force of 440. Yeah. Why these ones on red? Yeah, they are carrying 4.432. That means the force coming to them is very, very low. And to these ones on red, they are mostly the ones on top, because what they are carrying is roof load. Remember, in column, the load is being transferred downward, in the sense that this beam and this beam will transfer east load to this column. Then this column will not transfer east load to this column, and then this beam and this beam will also transfer east load to this column. Then this column now will not transfer east load to this yellow column. Then this one and this one will not transfer, this beam and this beam will also transfer east load to east column. Then this column now, this column on top will transfer it to this one. Then this and this will also transfer east load to this. Then this column will not transfer it to the foundation. Why foundation will not transfer it why the foundation will not transfer it to the soil, then the soil will not carry the load. So that's why these ones, they are the ones on this red color. Why, if the column is moving downwards, if the column is moving downward, you see it will be moving up. That's here. Okay, let's use this one for example. Look at it. The top is this color, followed by orange, then followed by yellow. Look at it, then followed by green, the green here. So what I want to explain is that all my perimeter column, they are carrying a lesser load. Yes, they are carrying a lesser load. If you check, all of them are from green downward. Why all this column inside, all my column that are inside, they are carrying a very heavy load. That's why you are seeing them blue, and few. In fact, all of them are blue. Look at it, all my inner columns, all of them are blue. So that's why my inner columns are failing. So what I will do in detailing is that once I come over to inner column, I will do them 225 by 300. That's what I will do. Once I come to my inner column, I'll do them 225 by 300. While for my outer columns, I'll do them 225 by 225 because they are kind of lesser load. Yes, I hope I've been explained. Look at it. Inner column, blue. All of them are carrying a very less load. Look at this one. Okay, just this one that is carrying a load that is somehow high. Look at it here. It's carrying 292. Yeah, it's load that is somehow high, but we'll still check it to know whether they are giving us 225 by 225. But if they're not giving us 225 by 225, that means all my inner columns will be 225 by 300 and my outer columns will be 225 by 225. Yes, because they are carrying a lesser load. I hope you understood this and I just explained that. These inner columns, they are carrying a very heavy load. That's why they are failing, and that's why it is 225 by 300. So I'll come over to this point. I'll come over and click on my plan view again. So let's enter.
If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you.
So I'll still check few of my outer columns. Yes, few of my perimeter column. I'll click on section design. Yes, I'm having it to be, let's wait for it. I'm having it to be this. Is okay. It's okay. I don't need to check more. Let me check this one. I know we're having that this one was a little bit. We're having that this one was, let's say, blue in color. So let's check what the software is giving us on this. So look at it. It's stay 4y16. So I'm perfectly okay with this. And also let me also check this one. Right click session design. Let me say session design. So let's wait for it. So I'm okay with this. Yes, I'm okay with this. But let me check one of these perimeter columns. Let's check. Let me see what is it. Okay, let me check. Let me see what this one is giving us. So I'll click on section design. So I'll click on section design. Let me see. Let's see. Okay, if you see, you can, it's even failing. That's why I say that all my inner columns will be 225 by what 300. So I'll come and make here 300. So I'll make it 300 update. Yes, then select bar interactive design. Then this is what I'm having 4y16. So I'm okay with it. And then I'll click on OK. So I'll click on no. Then once I click on no, I'll click on update steel bar. I'll look for it. Where's update steel bar? Update steel bar. Where is update steel bar? Okay, let me just escape. I'll escape. I click again. Update steel bar. So if you look at it, it has been updated. So that's why I say all my inner columns will be 225 by 300. Let me also check this one. Section design. This video is already taking long, but I believe that you're really learning something. So I'll still change it by 300. Update, then interactive design. So then you can get the CAD file on your own. You do the whole column. That's why I say don't just take whatever the software is giving you. Please don't just take it. Make sure you carry out your interactive design. It is very necessary. So this is what I'm having right now. Yes, remember I told you in detailing will be determine should this column be like this or should it be in this direction or should it be in this direction. That's when in detailing I will explain it to you. So make sure you watch the detailing of this video. So right now I think I've come to the conclusion of this. All my inner columns will be 225 by 300, and then coming over to this one now. This one now will be this one will be 225 by 300, but it will be 8 numbers of reinforcement, while the rest will be 225 by 300, but 4 numbers of reinforcement. Okay, remember, this building here and here is typical. So let me just check one. Let me just check this one. So I will be sure that I've checked everything. So I'll click on section design. Okay, it's giving me 4y16, but I'll still use 225 by what 300. It's giving me 4y16, but I'll still use it as 225 by 300. Yes, I'll click on okay. I'll still use 225 by 300. So I'll escape. Remember, some of our columns we are filling in story 2. So I'll come over to story 2. So look at it. This one is failing. So I'm sure if I'll just click on it and I will still be having 225 by 300 at that thing that I said. I said that all of them must be 225 by what 300. So I'll just say 300. I'll click on update.
interactive design. Then this is what I'm having 4x16, so I'm okay with it. And then I'll click on OK. So I'll click on no. Alright, click on update steel bar. So this is what I'm having. So right now, what I know is that all my inner columns will be 225 by what? 225. Sorry, all my inner columns will be 225 by 300. Why all my outer columns will be 225 by 300, 225 by 225. Why this column now will be 225 by 300, but 8 numbers of reinforcement. So because of the length of this video, I will not be doing all of them. So what I'll be doing next is just the slab design. Yeah, the slab design. So I'll come over to story 1. I would like to do the slab design on story 1. So on your own, if you get the CAD file, you can just finish up everything. I've made the conclusion. I've drawn conclusion from my result. So I'll come over to slab design, but on my own, I'll only check all my whole columns. I'll check the whole columns. That's if I'm doing it on my own, but because of the length of this video, I will not be doing everything. So to do the slab design, I'll come over to modeling. I'll come over to modeling, come over to slab slips. Yeah, slab slips. So once I'm here, what I'll do is that, remember, boundary condition. So for example, this, okay, I'm doing for S-axis first. So this is the boundary condition, this and this, because this is void, beam, and then slab. Look at it, void, beam, and then slab. And the ending back condition, look at it, beam, sorry, slab, beam, and void. Look at it, slab, beam, and then there's a void at the back. So these two are my boundary condition. So I'll click on this point, hold my control key, then click on this. So this is what I'm having. And also that boundary condition is still applicable to this point. Yes, it's still applicable to this point. Yes, so this is what I'm having. And that boundary condition is also still applicable to this point. Okay, wait, let me escape, sorry. So let me zoom very well so I'll get it. I'll hold my control key. Let's wait for it. I'll hold my control key. Yes, I've designed this slab. Then coming over to this point, and the boundary condition have changed. Look at, I'm having a slab, a beam, and then a slab. Then here, a slab, a beam, and a slab. So this will be my boundary condition. A slab, a beam, and a slab, a slab, a beam, and a slab. So these two will be my boundary condition. So I'll select both of them. Then I'll click here, hold my control key to straighten the line, and then click on this. Yes, this video is taking long, so that's why I'm a little bit fast. Yes, to save time. Then I'll come over to my Y direction. So my boundary condition is this and this. Yes, a void, a beam, and a slab. So I'll come, look at it from this point. I'll hold my control key to straighten the line. I'll hold my control key. This is what I'll be having right now. Then then I'll come to this point. Then the boundary condition has changed. Remember, we have designed this beam already. So this will now be my boundary condition. A beam, sorry, a slab, a beam, and then a slab. So this will be my two boundary conditions. So I'll have this beam running like this. From this point, I'll hold my control key to this point. Yes, so this is what I'm having. Then the boundary condition have changed again. Look at, here is a void and here is a void. So these two will now be my boundary condition. So I'll move from this point to hold my control key. Okay, I'll hold my control key to this. So if you see, it has been designed. So let's check something. Let's check. I'm having T12 at 250. T12 at 250, but doing detailing, I will not use T12 at 250. I'll be using T12 at 200. There is a reason for that, to prevent building collapse, because remember, this is I'm located in an African country, and to here they tamper with quality. If I go to the market now, this T12 is no longer T12. It will be something like T10 or T11. Yes, because the company, the production company, they want to make gains, so that's why they will reduce the quality. And to remember, the yield strength that we use is what, 460. So the yield strength at market will be something like that, kind 410, 420. It will never be up to 460. So to counter all these losses, I will now decrease the spacing, so that, because once I decrease the spacing, what it means that I've increased the area of T provided. Do you understand? Once I decrease the spacing, moving from moving from T12 250, I will now do it T12 200. I've decreased the spacing, meaning that I've increased the area of tear. That means I'll be able to counter those losses. In fact, I'll just advise you generally, once you come to slab, make sure that your slab, the minimum spacing that you use in slab, that's my advice, just use
200. That should be your minimum spacing once it comes to slab. So with this now, I believe that we have come to the end of this video. So this is what we have done. We have been able to, let's wait for the 3D view to appear. So look at this slab. I've been able to design this slab. Then on your own, you can get the CAD file. On your own, you design this slab, and also on your own, you carry out the interactive design of all the beams, of all the columns, and also design the slab on your own. Don't forget, you can share this video so that more people will get to learn. Don't just learn alone. And also, you can get the CAD file and practice on your own, because practice makes perfect. If you watch 100 videos without practicing any, and another person just watch only 10 and practice those 10 videos that you watch, I bet you that person will be far better than you. I know how I got good in structural design. That's why I'm saying all this. So invest in yourself now, so it won't be too late. Do you want to master structural design in just 10 days? I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube.
Day one of this course is all about structural framing, also known as general arrangement drawing. Here, we will master the governing principles in column placement, beam placement, and slab paneling. Day 2 is all about modeling in ProtaStructure, where we will model our architectural plan using the software ProtaStructure. Day 3 is all about analysis and design, where we will analyze the forces acting on each structural members, that is slab, beam, column, and foundation, and then design the reinforcement required to counter those forces. We will also learn interactive design, where we don't just accept what the software suggests, but validates it using manual engineering principle. Day 4 is all about foundation detailing. Day 5 will be about path-based footing detailing. Day 6, column detailing. Day 7, beam detailing. Day 8, slab detailing, and you will understand the governing principles in slab reinforcement, that is, how to place your top and bottom bars and how to detail a slab section. Day 9 is all about staircase detailing and east sectioning. Day 10, you will learn how to print and present your drawing in a way that looks professional. In this course video, you are going to get the architectural plan we use and also a complete structural design drawing of this architectural plan. And finally, you will get a step-by-step video course on structural design and detailing of this architectural plan. For now, I'm giving it out at 80% discount. If you buy it today, you will get it at a discounted rate, and we have bonus packages for the first 100 people only, which includes structural design and detailing template I personally use, structural engineering CV template to help you stand out for any job application, free installation of ProtaStructure and AutoCAD software, and finally, access to our online engineering community, where we share engineering tips on daily basis so you stay sharp and never get outdated. But all this is only for the first 100 people to subscribe. Don't miss this chance to close the gap between theory and practice. Click the learn more button and get the course now.
And in this video, we are going to be doing the foundation design, and we'll be using beam raft foundation. Yes, in this structure. Reason why we chose the beam raft foundation is because the soil bearing capacity we got from the soil report is 70 kilonewton per meter square. So the soil is very weak. Yeah, the soil is a very weak soil. That means the load will not be distributed evenly if we use part foundation. So for that reason, we'll be using beam raft foundation. So in beam raft foundation, let me turn on my layers. I'll turn on my layers. I'll turn on my axis, turn on my ghost axis, turn on my print definition, and also turn on my test. So right now I've turned on everything. So I'll be going to plan view. We want to carry out our foundation design, that's the beam raft foundation. Then I'll come over to story 0. Yeah, because we are talking about foundation, so I'll come over to story 0. So if you can see, I'm not seeing the beam line we did in AutoCAD doing our original element drawing. Yeah, I'm not seeing it in this foundation plan. So to see it, I'll come to this external reference drawing, that's under building setup. I'll come to external reference drawing. I'll click on it, yes, and then come to this story number. I'll select story 0, yes, and then click on OK. So right now I've seen this thing. Reason why I brought this thing to this story 0 is so that I'll be able to model my beam. Yes, because you know beam raft foundation is all about beam. Yeah, so I'll be able to model my beam. So I'll come over to modeling and then click my beam tab. Yes, so look at this. I'll click my beam tab, foundation beam. So yes, that's what I want to model. I'll click on OK. So right now we'll be using
the column, we will be using the beam size of 225. Yes, we want it to still be the same column size that we have. So beam size of 225 by 225. Then, but the depth of our beam now will not change. If the depth of your beam is less than 1 meter, if it is less than 1 meter, that means, so if it is more than 1 meter, that means it will be designed as a shear wall. But if it is less than 1 meter, that means what you are designing is not really a beam raft foundation. Is right? Say it is called wide strip foundation. Yeah. But if it is above 1 meter, that means you are designing for a beam raft foundation. So the depth I'll be using in this building is 1 meter. But if it fails, I'll come back and increase it. Yes. If it fails, I'll then come back and increase it. Maybe I'll not go for 1,200 millimeter or so or thereabout. But for now, I'll be using the depth of beam to be 1 meter. Remember, this is foundation beam. This is not just a normal beam. This is just our foundation beam. I chose 1 meter so that the load will be transmitted to the soil evenly. Yeah. So with this now, I've chosen everything. So I'll just come and model my foundation beam. Yes, I'll just follow this beam line that we did in ProtaStructure. Just model my foundation beam. Yes. So if you see, it is white in color. Yes, the reason why it's white in color is because this beam now, I've not yet designed it. Let's go to 3D view. So if let's go to where we have designed. Look, if you can see, it is white in color. Reason is because I've not yet designed this foundation beam. Yeah, but in which I would like to turn off this design status. I would like to turn it off. Then click on it. Then click on. I'll come to none. I'll click on none and then click on OK. So after I'm through with the design and everything, I'll then turn it on again. So I'll go back to my plan view. Once I come over to my plan view, I also like to turn it off here. So I'll turn off my design status off here. I'll click on this, then click on OK. Then I'll come back and double click on this. Sorry, and double click on this to pick its property. Yes, I'll double click on it. Then I'm having this from this point to this point. Yes, I'll escape and then I'll do for I'm having, okay, let me come to this side. I'm having from this point to this point. Yes, I'm also having, sorry, I'll double click on this again. I made a mistake. Then I'll move from this point to this point. So right now I want to just trace all our beam. Remember, if you do not follow this video from the general arrangement drawing, I will advise you to go and watch the general arrangement drawing, so you get to learn a lot. So because in that general arrangement drawing, we were able to explain a lot of things. Yes, both the governing principles in column placement, in beam placement, and even in paneling. So if you watch it, I bet you will really learn a lot. Yeah, you will really learn a lot. So sorry, I made a mistake. I'll double click on this. So, and also try and get the CAD file and practice on your own. Yes, because practice makes one perfect. The more you practice, the more you get to learn. So try and get the CAD file and then practice on your own, so you know it very well. So remember, if you just watch 100 videos without practicing any, and someone watches only 10 videos and practice only that 10 videos that he watches, I bet you that person will be far better than you. And that person will be far better than you. So right now, what I'll do is that I'll pause this video and just input all my beam. Once I'm through, I'll then resume back. Right now, I'm through inputting all my beams. Yes, I'm through with all my beams. So what I'll be doing next is to input my slab. So I'll come over to modeling. Yes, I'll come over to modeling, then double click on my slab. So I click on my slab. So what I will be having as my slab is I will be using the slab depth of 200. Yes, because this is a foundation. This is a foundation slab, not a normal slab. So I'm using the slab depth of 200. I'll still leave the concrete cover at 35. Yes, I'll leave the concrete cover at 35. That's the bottom, but the top I might use it. I will now doing the then I'll use the top concrete cover to the 25. Then coming over to my loading, the same dead load, I'll be using 1.5 based on what I've explained earlier. That is partition load and finishing load. Partition load being 0.5 and finishing load being being 1. Then coming over to my imposed load, I right click on general domestic use. So this is what I'm having right now. Then I'll come over and start inputting my slab. Yes. But let's check something. Let's come over to our 3D view. Let's check. So if you look now, look at what you are seeing. This slab is being placed at the bottom, but we are not supposed to have this slab at the bottom. We are supposed to have it at the top. So to bring it up to the top, what I'll do, let's come over to plan view. Let's come over to plan view. So I'll double click on this beam, this slab again. Then come to this relative level. I'll do 1000, which is the depth of my beam minus the depth of my slab. So 1000 minus, that's 1000 minus 200. I'll be having 800. So I'll then click on update. Once I click on update, let's go back to our 3D view. So if you see now, look at our 3D view. Look at it, and it's not up. It has gone up. Look at it. I have seen it. So this is how it should be. So I'll come over to this my plan view again. then double click on it to pick its property. Remember, I'll place it here, I'll place it here, place it here, place it here, place it here, and also place it here, and also place it here, place it here, and I'll also place it here and place it here, and I'll still come and then place it here, place it here, and I'll place it here and place it here. The one I place here did not appear. Then I will come and okay, I'll place it here again. Then for this one, I would like to use a beam and divide here. So let me escape. I will double click on this. I'll double click on this. I would like to divide this into two. You know, these are staircase region. So here was void in our story 1, story 2 to story 4. It is a void. But in this case, this is a foundation beam. It's not a void. Yeah, so I would like to use that beam and demarcate it. So let's see what we have done in our 3D view. So looking at from our 3D view, this is what we have done so far. This is what we have been able to accomplish. Yes, so the next thing right now is to design our slab. That's to input our slab strip. So that I'll come over to story 0. Then we have to input our slab strip. So once it comes to superstructure, that's from story 1, story 2, story 3. How it is being done is that after your design, then you now come and design your slab separate. Yes, after your analysis and design, now come and design your slab separate. But once it comes to foundation, the way it is done is that before you design anything, you first of all draw your slab script. Yes, because during the analysis and design of this foundation, it will also design and provide the reinforcement for the slab. So before you do your design, make sure you input your slab script. So for that, I'll come over to modeling, click on this slab script. So this dialog box will appear. Remember, in our superstructure, we use analytical model, but this is foundation, and this is a beam raft foundation. So we are using finite elements. Yes, we are using finite elements. So I'll come over. This is my S direction. So what's the boundary condition? So we'll be doing from this point down to this point. So the boundary condition will be this, which stands for void, beam, and slab. Look at it. The end is void, then we're having beam, and then we're having slab, and this is also the end boundary condition. So I'll come over to this point. Then I'll hold my control key and place it here. So if you see, I've placed my slab strip at this point. Then next one I'll do now is from this point to this point. Yes, I'll click here from this point. I'll hold my control key. To this point. Then next one is just from here to here. Then I'll hold my control key. I hope I got it well. No, let me escape. I not get it well. So I'll come ahead, I'll place it here. Then hold my control key to straighten the line and place it at this point. Then if you see, after all this, the slab that we did, it not cut across this slab. Yes, it not also cut across this slab. So for that reason, we'll come and run the slab strip for this slab separately. So if you see, it is surrounded by slab. So the boundary condition will be this and this. So I'll do from this point to hold my control key to straighten it to this point. Yeah, so it will design for this slab. Then I'll also come over to this point and hold my control key from here to here. So look at it. Then after this, the next thing is to do for the vertical direction, that is the Y direction. I'll come over to this and click on my Y direction. So what is the boundary condition? I'll still pick these two things as my boundary condition. Then I'm having the slab to run from, I'll hold my control key to run from here. Let me hold let's wait for it. It will run from here. I'll then hold my control key to straighten the line. I'll click on this point. So coming over to this point now, we're having here. Remember, we have designed for this slab, so we will stop here. So that means this is our starting boundary condition, and this will be the ending. The boundary condition, the end boundary condition, because we're having slab, beam, and slab. Yeah, so this will be the ending back condition. So I'll pick this point, then hold my control key to strengthen the line, then click here. So I'll come over and decide and set this is now my new boundary condition for this one. Now I'll move from this point, hold my control key to this point, and for this one too, I'll also from here to hold my control key, and for this too, from here I'll hold my control key. Then for this one now, the boundary condition will be this, because it will be okay. Don't worry, let me just do for this one. I'll click from here and then hold my control key. Yes, then once it comes to this side, since you have designed for here, I'll now do from the extreme. I'll pick this extreme part. Yeah, so it will design for only this slab. So this is what I'm having. I'll click on this. So if you see now, I've successfully run my slab sleeve across this whole slab. Okay, there's something I want to explain here. Let me remove this. There's something I want to explain here. For example, let me explain using this column. Once you come over to this column now, let me say this column is carrying a very high load. So at this point, this column will spread its load around this slab. Yeah, it will spread its load around this slab. That means this slab now will not help to distribute the load coming from this column to the soil evenly. Do you understand? This column now will spread its load around this slab, and this slab will now help to distribute its soil, to distribute its load evenly to the soil. But coming over to this perimeter columns, that's this column at the edge. Yeah, if you see this column now, it will only spread its load around this slab. Yes, it will only spread this column around here. There is no slab around this area for it to spread its load to, like for it to distribute its load to, so that that slab will not distribute it to the soil. That means in our design, there is high probability that we'll be having failure around this edge, around this edge, around this edge, in fact around the perimeter columns, this column, around this column, around this column, around this column. Reason is because the load coming to this column is not being spread to the soil evenly. Yeah, the load is somehow concentrated at this point. That means it will cause something like punch on the soil, and causing that punch on the soil, it will result to failure. But in this case, for this column now, if you see, the load will be spread around this slab, then this slab will now distribute it evenly to the soil. Why here now the load is not being spread, the load will be spread around here, while this side is still void. There is no slab that will help in spreading this column load to the soil. So for that reason, we'll be introducing a cantilever slab around the edges of this beam raft foundation, around the whole edge. We will be introducing a cantilever slab so that it will help and spread the load coming to this structure evenly to the soil. If you do not introduce this slab, I bet you most of the time it will fail. Yes, it will fail. Or if you don't want to introduce the slab, you can go and introduce a very high beam depth, but I'll advise you just introduce a slab. Yeah, so but we'll be going with the minimum cantilever length of 500. Then if it fails, we'll then come back and then increase it again. We'll be going with minimum cantilever length of 500. So I hope you understood what I explained, the reason for introducing this slab, to help and spread the load coming from this column. Yeah, because if the load is not being spread, that means the load will be concentrated at this point. And if the load is concentrated at this point, it will cause punching on the soil. And once it causes punching on that soil, it will fail. So to help spread the load, we are introducing a cantilever slab. So I'll come over to this slab, click on my slab, then the slab that I would like to use is still 200. Yes, the still 200. Then I'll come over to this point. Okay, the concrete cover, I'll still like to use a concrete cover of 35. Then coming over to this point, I'll pick cantilever length of what? 12. Then I'll leave the load. I will not apply anything on the load, because the only load I'll be applying here is the soil load. Or I can just choose to apply the soil load, because it's only soil that will be resting on it. That's the soil load. I can just choose to apply the soil load to be 0.5. Yes, I can just choose to apply the soil load to be 0.5. Then I'll not apply any other load again. Then I'll come over to this cantilever length. I want to choose the minimum to be 500. Then once it fails, I'll then come back and increase this length. So I'll start from this point. I'll move from this point to this point and then extend it out. I'll move from this point. Hope you understood what I explained. For this point and then extend it out. Move from this point to this point and then extend it out. Yes, and then I'll also move from this point to this point and extend it out. Reason is so that the load coming to this column will be spread evenly. Yes, it will be spread evenly. Hey, sorry, I made a mistake. I'll cancel. Remember, assuming I did not include this cantilever slab now. Okay, let me just do this. Assuming what's going on? Okay, look at it. Assuming I did not, okay, at this point now, what will happen is that at this point, this column will now spread its load to this slab and also to this slab. Then this slab and this slab will now help and spread its load to the soil evenly without causing much failure. So that's the reason for introducing this cantilever. Then I'll introduce it here. Yes, this is what I'm having. I'll move from this point to this point. I'll bring it down. Yes, this is what I'm having. I'll move from this point to this point. I'll bring it down. So right now I'll pause this video and do everything, so I'll not waste time. Remember, you can get the CAD file and practice on your own. Yeah, so it's not just about watching this video. If you practice it, like, it will become part of you and you get to know it more. Yeah, it will become part of you and you get to know it more. But I'll be pausing this video right now. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you. So right now we have two inputting our cantilever slab. So if you can see, this is what we are having right now. But let's go over to our 3D view and see what we have done so far. So this is our 3D view. Let me turn off my axis. Yeah, let me turn off my axis so you see it clearly. So I'll turn off this, and also turn this off. So this is what we are having right now. So if you can see, we have successfully modeled this beam lath foundation. Yes, so the next stage now is to go to our setting. Yeah, go to our setting, input our soil bearing capacity, not just that, and also do some other settings once it comes to foundation. So right now, let me turn on everything. So I'll click on display, click on layer, I'll turn on my axis, I'll turn on my ghost axis, my plane definition, and my desk. So everything has been turned on. So next thing now to do is to come over to my settings and do some settings. So I'll come over to my settings, then come over to foundation. So this is my foundation. Yes, and input my soil bearing capacity. Remember, we said that the soil bearing capacity we have here is what, 70 kilonewton per meter square. The soil unit weight is, you just leave it like this. This is the soil unit weight. And also coming over this subgrade coefficient, you leave it like this. If you want to change it, that means you have to go over and change it. That's if you know about the subgrade coefficient well, or you can read it up in Joseph Boyce. Yeah, you can read it up there so you get more knowledge on it and change it. But I'll advise you to leave it at this, because this is just the general value that we use. So I'll click on cancel. Then the lane concrete thickness. The lane concrete thickness is just like the branding. Yeah, the branding. That's a weak concrete that will first of all lay. You know what is branding? Brand is just a very weak concrete. We are just trying to avoid letting our beam or our beam lab foundation have direct contact with the soil. So for that reason, we lay our branding. So they're asking of what is the lane concrete thickness. So I would like to use 50. I don't want to use 100. And what is the lane concrete extension? That's if you are extending it, just make it as 50. I also like to use 50. So this is about split footing and this is about part foundation. So I'll still leave this at default. And most of the things here are about part based foundation. So I'll still leave them at default. And then coming over to my steel bar 16, so I'm okay with it. That's for my beam. I'm also okay with this. So I'll come over to this point and then click on okay. Yeah, so click on okay. So once I'm through with this, next thing to do is to carry out my analysis and design. So I'll come over to this point of analysis. I'll click on FE foundation analysis. I'll click on it. Once I click on it, this dialog box appears. So I will check this to use the subgrade reaction value assigned to slab for soil stress check. So I'll check this. I'll also check this. That's to include conus section in FE model. I also check this to consider beam torsional stiffness, and I also check this to release column top node in S and Y direction for FE foundation model. So I'll check these three things. Then this one, apply load reduction. Remember, when we are editing our story, I talked about load reduction. Load reduction is normally used in high-rise buildings. Yes, they are normally used in high-rise building because not all the soil will be in use at all times. So that is when we do apply load reduction. But I will not use this. This one say display analytical model before analysis. I will not like to check this. You just once you start analysis, before they will analyze, they will not display for your analytical model. I don't want this. I want to be fast. Then this one, use space solver for analysis. Don't check this. I will not also check this. Don't also check this. Then this one, refresh the connectivity information of all beam member. I'll just leave this at default. I'll just leave this. Then coming over to this one is the shear element size. So this thing now, the lesser it is, the better. Yes, the lesser it is, the better. I'll still show you what this shear element size means. But if the lesser it is, the better. But the thing that the lesser it is, the more time your analysis will take. So I'll come over to this point and click on floor mesh and analysis. So I'll click on this. Then once I click on this, let's wait for this thing to load. Look at it. It's already designing arrival soil stress. So look at it, it's already designing. So this is what we're having now. Arrival soil stress 1.2 and shake will based on this water pressure. So this is what we're having. So let's wait for it. It's designing. Remember, you can still get the CAD file and practice on your own. And also, if you are finding this video helpful, you can share it in your class group if you're a student, or in your work group if you're a practicing engineer. So they say foundation beam effect is being updated. I'll just click on OK. Yes, so I'll click on OK. So look at it, analysis completed. So once it's analysis completed, I'll come over to this point, display analytical model. I'll then click on it. I'll click on it. So let's wait for it to display the analytical model for us. Remember, you can share this video and also like it if you are finding it helpful. Yes, share it so that more people will get to see it, and also you can get the CAD file and practice on your own. So this is the analytical model. So look at what we mean by that share element. So if you see now, look at that 1000, look at that 500 and 1000 that I'm showing you. Assuming I choose any value less than 1000 or less than 500, this triangle will be smaller. Yeah, this share element, it will be smaller. What it also means is that the analysis will be more accurate, but I will just advise you to just leave it at default. So this is what we are having. If you want to check the animation, so you click on this to see the animation, but we don't need it right now. So what I'll do is I'll come over to this point that says contours. I'll click on contours, then come over to this point and then click on contours. I'll click on this, then a dialog box will appear here. Let's wait for it to appear. I'll click on this. Let's wait for the dialog box to appear. So look at it, it has appeared. So right now we will begin to load we will begin to load all this into our structure. We'll begin to load all of them in our structure. So let me have it. I want to have it like this. Okay, let me click on just top view. Yeah, the top view. Yeah, okay, and then I'll zoom. So if you can see, look at it, anywhere that is purple in color, that means the road coming to those area is very, very small. Yes, if I'm having purple color, that means the road coming to is very small. If I'm having red, that means the road is increasing. Why the point that is blue in color means that it is those points that have the highest load on acting on it. So that's why I included this cantilever slab. So if you see, it's all these edges that are blue in color, because the load coming to this part is very high. That means maybe it might be that after designing this it might fail, but I don't know. Let's just design. So look at this, look at it. We're having column here though, so here is blue. So it's because assuming I increased the cantilever slab, assuming I made it something like 1800, that means the load coming to it will be lesser. Yeah, because that cantilever slab will be able to distribute its load to the soil. So let's just continue the analysis. Look at it. It's all these edges that are blue in color, meaning that the load coming to these edges are very high. Reason is just because this column do not distribute its load very well to the soil. If you look, all these center columns, look at them, they are just green. They are just green in color because their load we are distributed to the soil evenly. That those top slab around it helped in distributing its load to the soil. So right now, what I'm doing now is to load this structure. So I'll come over to this point and just be clicking them one after the other. So I'll allow it to load. Yes, I'll also come and click on this and I'll still allow it to load. So look at it now. I will come and click on this and also allow them to load. So right now we are through with this. So next thing is to come and load the forces. Yes, I will allow it to load. And load this horse. I'll just be doing it one after the other and I will allow them to load. So I'll also click on this and allow it to load. I'll also click on this and allow it to load. I'll also click on this and I'll allow it to load. Yes, I will click on this too and also allow it to load. So look at it. So we are through with the forces. We'll come over to the bending moment. I'll click on bending moment in direction 1. I'll click on moment in direction 2. Yes, moment in direction 2. So this is what we are having, is still the same thing. Then I will now click on this moment in dimension 1 and 2. That's the torsional moment. So let's allow it to load. So this is what we're having now. I'll come over to the design moment. I'll just be loading it on this structure. I'll be clicking on it so it will load on this structure one after the other. So this is what I'll do throughout. I've clicked on this and also look at this. I will still allow it to load. Remember, we are still going to do the beam route detailing. We are still going to detail this in AutoCAD, so you can still check it. Yeah, you can still check our video where we did the detailing, so you see it. Yeah, after this now, the next thing is detailing. We'll enter into detailing. So where I forgot to explain something. This is the area of steel required. Yeah, this is the area of steel required. But normally, I always like to use this second area of steel, and I'll still explain something using this second area of steel. Yeah, so this is what we're having. This is also what we are having at this point. Yes, then coming over to the area of steel. Look at, I'll click on this. Look at what we're having here. So in this thing now, you can use your steel table and provide reinforcement using this. Yeah, you can use your steel table and provide reinforcement using this, or you can go with the one that the software gave you, any of them. So I'll also come over and load this. Yes, I'll click on this and load this. I'll also load this. Yes, and I'll also load this. I'll also load this. So the area of steel here is 170. So I'll also come over to this soil pressure and also load this. So coming over to my soil pressure, I'm having it to be 72. So if you see where we are having this soil pressure is at this extreme. So this is why we inputted the cantilever slab to be able to spread this load. But if you see the pressure at this end, they are still much. That's why we are having 72. The pressures at this point, they are still much. They are still much. But look at the check that you must do. You must surely do this check. What is that check? Let me bring out my calculator. So if you can remember, the formula for ultimate load in Euro code, remember we are using Euro code. The formula for ultimate load in Euro code is 1.35 GK. GK means dead load plus 1.5 QK. QK means life load. Yes, that's the formula for Euro code. So in this case, we have what is coming to this structure now, we are assuming is the dead load. So here we are going to do 1.35 times what is our soil bearing capacity. We use the soil bearing capacity of 70. Yes, so we are having it to be 94.5. Please make sure that this value that you are getting here is more than the value here. Yes, make sure it is more than the value here. Look at it. We're having 94.5. While here we're having 72.1. That means because the load coming to this, the highest load this structure will transmit to the soil is 72.1. Yeah, that's the highest load that this structure will transmit to the soil. And two, the highest load this soil can carry is this 94.5. It is gotten from 1.35 GK because we're using Euro code. That's why we use 1.35. But if you're using Euro code, you use 1.4. Yes. So the highest load the soil can carry is this 94.5. While the highest load this structure will transmit to the soil is this 72.1. So if you can see with this now, that means the soil will be able to carry the load coming from this structure perfectly. Yes, it will be able to carry the load coming from this structure perfectly. But assuming you not input this cantilever, I promise you it will fail. Yes, because the load will not be distributed very well at this country at these edges. Yeah, that's why I say you must input the cantilever and to try and go with the minimum of 500. I hope I've explained this thing well. So if you want to see your solid model, yeah, let's wait for it to load. In case you want to see your solid model, let's wait for it to load. In case you want to see your solid model. So in case you want to see your solid model, so this is our solid model. What does this thing mean? Look at it. Blue means the highest load. That means this is the column carrying the highest load, and this is also the column carrying the highest load, and this is also the column carrying the highest load. And if you can remember during our interactive design, yes, it is this column is this column that we are referring that will increase to 300, that will increase from 225 to 225 by 300. Yes, that's why I now say that all this column inside I will be using 225 by 300 for all of them, because if you can see now, look at here, look at here. If you can see, is all this column inside that are from this point to this point, is all this column inside, because the load coming to them is high and the load coming to this external ones is small. That's why you'll be seeing them. They will be ranging from here downwards. Yeah, from this green downwards. That's why I say that all my inner columns I'll be using 225 by 300. Why all my outer columns I'll be using 225 by 225. Yes, because the load coming to them are not really that heavy. If you want to learn more, or if you want to hear more of what I said based on this, you can go to where we did the analysis and design. So right now we'll be going over to the beam design. We are through with the foundation design. We'll be going over to the beam design. So I'll come over to my plan view. Yes, I'll come over to my plan view. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you. So once I come over to this plan view, look at it. Our FE foundation analysis, it has been checked good, means it has been designed. So but right now I'm not seeing my reinforcement design, like the reinforcement that was being provided. So what I will do is that I'll right click. First of all, yeah, I'll right click. Let's wait for it. I'll right click, then click on update steel bar. Let's wait for it. Let's wait for it. Yeah, it's loading. Look at it, it's loading. Don't worry, you still see it. What a hair. So look at it now. So this is what that was being provided for us. Hope you can see it. So look at what is being provided for us. T16 at 250, T16 at 250 at the top, and also T16 at 250 at the bottom. So if you see all the provision they made here is what T16 at the top and T16 at the bottom. But you need to see something. But I'll explain more on this once it comes to detailing. So if you see this T16 at top, look at it, is the one running across this slab. Why this one that is we normally provide for moment in normal slab, yeah, in story building slab, in normal slab, look at it, it is now bottom. But this one that we used to place at the bottom in normal slab, they put it as top, and this one we used to provide as the moment, that's the top reinforcement in normal slab, they put it as bottom. Is correct, but I'll explain more on this when it comes to what detailing. Yes, when it comes to detailing, because you know before this, don't worry, I'll explain more on it when it comes to detailing. If you want to understand it more, make sure that you watch the video that we are going to do about this beam raft detailing. Yes, it is for free. Yeah, I'll make it for free, so it's for free. So if you can see this normal one, normally in our slab we used to call this the B1 or B2. Why this one that is for continuous beam, we used to call it T1 or T2, but if you see it has been changed. Okay, let's go over to story one. Let's go over to story one so you see what I'm explaining. Let's go over to story one. So I'll double click. So look at this is our story one. So look at, have you seen it? This one that land across here, I'm having it as what? B1 as B. Okay, let me check for another one. Okay, look at it here. Look at here. Look at this one that run across here. I'm having it as what? B. And this one, once you come over to this one, I'm having it as what? T1. But once it comes to foundation, it's different. It's correct, yeah. But but once it comes to detailing, that's when I'll explain this very well for you to understand. So right now, let's go over to foundation. So right now we have done our we are through with our slab design. Next thing is to design our beam. So to design our beam, I'll come over to this tab named design. Then I'll come over to beam design. Look at it, foundation beam. So I'll click on this foundation beam. Look at it, it is marked bad because we have not yet designed it. So once we come to this place, I'll come to this beam design bash mode. So I'll click on it, then I'll click on reselect all bars, so it will design my beam for me. I'll then click on calculate. So let's wait for it as our beam is being designed. Don't forget, make sure you watch the beam detailing of this. It will be, the link will also be pasted in this video description when we do it. Yes, I'll paste the link there so you get to learn a lot. You are going to learn a lot about beam detailing. Yeah, for example, what I just showed you now about top reinforcement and bottom reinforcement, when they change, what's the reason that they change? You get to learn it because I'll explain it there. So in this case, I'll click on close because it has been designed. So look at it, it is being marked good. We will still do our interactive design. So I'll close this, and then I'll come over to my display to turn on my to turn on my design status. So I'll click on this. Let's wait for it to appear. So I want to turn on my design status so we'll know the beams that are failing and the beams that are passing. So I'll click on this and then click on OK. Yeah, so if you can see, oh, we made a mistake. I forgot to run our slab strip across this cantilever slab. So if you see it, it is not designed. It is not designed. Yeah, but I know that if I should assume I designed it, I will still be having this T16 at 250. I'll still be having this T16 at 250. And to note, once it comes to detailing, I will not use T16 at 250. I'll use T16 at 200. Because of what I have been explaining. Yeah, once it comes, I'm located in one of the African country, which is Nigeria. Once it comes to most of all these African countries, they tamper with quality. Yes, their T16 is not T16. Their T16 can be T13, T14, or T15, and thereabout. And the 460 yield strength that we use might be 430, 440, or thereabout. Yeah, because they are trying to make profit in their production. So for that reason, I'll try to counter that to prevent building collapse. So I did not do this design. So no, but normally as we were to do the design, I'm sure that you can do it. Once it comes to slab strip, you go to finite element and then you use the boundary condition for cantilever. Yes, so but in this case now, I'll just do the interactive design of few of these beams, not all of them. I'll just do for few. So to carry out my interactive design, I'll come over to this foundation beam. I'll click on it again. So if you see, as we have designed it before, all of them passed. So but I'll be checking them one after the other, but I'll not do all of them in this video. When you get the CAD file, you can practice on your own. Then at this stage, you now check all of them on your own. I'll just pick random beams. Yes, I'll just pick random ones. So I'll double click on this. Let's check on this. So this is what we're having now. So if you can see, this is what I'm having. 2y16, 2y16. I'm okay with it. But if you can see, they did not include web bar. Now let me include web bar and show you what web bar means. So in this case, I would like to include 2 web bars, and I would like it to be also 2x16. That's the web bar. So let me come to my detailed drawing and show you what the web bar is. So this is what is called web bar. This and this. If I see I included 2, that's what I'm having 1, 2. Yes, the reason for this web bar is because of shear. You know, this is a very deep beam. It's a deep beam. So if I not include this web bar, this beam now might twist and it will fail due to twisting. So to prevent that twisting, that is why we do include this web bar. Yeah, to prevent that twisting, we include web bar. So you must include web bar even though the software do not provide it for you. Once your beam depth is more than 600, you must have web bar to prevent that twisting from occurring. So I'll click on it. So you can see the software do not provide web bar. So we are going to check many of them to be sure that software provided web bar, and if they do not provide any web bar, we will include our web bar. So I'll come over to this point and click on OK. So I'll pick another 3 random beams and then stop. So I have this. Look at this one. I would like to click on this. Remember, I say I'll just pick it at random. So this is what I'm having right now. 2x16, and coming over to this support bar. Look at this. This is the support bar. I will decrease it. So I'll decrease it. I'll remove it. What I'll do, I'll come over to this point and I'll extend left to wrap. I'll extend left to wrap. Yes, this is what I'm having. And coming over to this point, and I'll also extend right to wrap. I'll extend right to wrap. Extend right to wrap. So look at it. This is what I'm having. But it is still failing and it is still less than 100. So what I'll do is I'll come over to this point and input one top bar. Yes, I would like to make it to be Y16. So this is what I'll be having now. Then I'll come and include my web bar. Which is 2y16. Yes, 2y16. I'll also come over to this point, include my web bar, 2y16. Yes, this is what I'll be having. So let's go over to our detailed drawing. So let's shake. So in this case, this is what we'll be having here, and this is our sectioning. So in this case, I'll just come and click on close and then click on OK. So this is what we are going to do for all of them. Now I'll come and check on this one again. This might be my last one. So this is what I'm having. So I don't want this. I will then click on this one, extend right to wrap. I'll click on extend right to wrap, then click on this, extend left to wrap, extend left to wrap, extend left to wrap. Then I'll leave it like this, then include my web bar. So 2y16, that's what I'll be having. I'll increase it to 16. So this is it. I'll come over to this point to 2y16. I'll also increase this 2y16. So this is what I'll be having. So I'll come and click on OK. Then on your own, once you get the CAD file, you can do everything on your own. So I'll come and click on close. So right now we have successfully model and design this beam raft foundation. In our next video, it will be about detailing of this beam raft foundation. So you can also watch out for it because we are going to learn a lot from it. Remember, if you found this video helpful, please do it to like this video. Yes, don't just like, you can as well share it in your class group if you're a student, and also share it in your work group if you're practicing engineer, so that more people will get to see this video.
Do you want to master structural design in just 10 days? I created a course where I carried out the full structural design of this residential building step by step. In this course, I broke down everything you need to know about structural design, starting from the fundamental engineering principle all the way to the practical detailing. Honestly, it is far more in-depth than anything you will find for free on YouTube. And think about it, if my free lessons are already this good, just imagine my paid courses where I poured out all my knowledge and real-life experiences. This 10-day structural design masterclass is all you need to become a confident and competent structural engineer. And the best part is, it is affordable because I consider that most of you are still students. So click the first link in this video description and access the course.